The old man built. The old man built. The old man built. The old man built. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man.
Hello, everybody, and welcome. My name is Nathan, otherwise known as Old Man Builds. Shawn, what's going on, brother?
Hey, I'm doing pretty well, thanks. I missed you guys. I've been gone for quite a bit, so thankfully my health is better, and Nathan and his gracious opportunity open for me. I can't wait to share with you guys what I'm doing.
Right on, brother. Let me bring it up, and I'll jump out.
Awesome.
It's all yours, Shawn.
Awesome, thank you. So, hey guys, this is my little cabin in the woods, and this is where my wife and I go for serenity and peace of mind. It's really quiet, and this is a spring-fed lake that our house is on, so it's a real peaceful place. Thought I'd share with you guys a little personal note. There's a whole backstory to this that I might share when we do a biography, but I thought it'd be fun to kind of share where I go with my wife when we rest, get some peace of mind. So, what am I working on? So, I pulled this electrode out. It's about 3 or 4 months old, and look at it. It's not only holding its charge, but it's actually stronger. I still don't have a better method than just holding the disc in front of the rotor. I haven't spent a lot of time on that, but good news. I would say about 10% of my electrodes actually work. So months later. So this is promising. I'm gonna do more tests on that, but I just want to let you guys know I'm gonna be building better, stronger electrodes now that my garage is cooler, now that we're in the fall. So thought I'd share that. All right, before we talk about RAVs, I wrote this little licensing document because it was important to me that people get credit where credit is due. And if you've noticed, at the beginning of every presentation I've made on the RAVs, I'd mentioned this guy, R.A. Ford. He's the guy that I read his book 33 years ago. And I built a circuit, actually, and I was surprised. This is my first high voltage circuit. And then I never touched a soldering iron for hobby use after that. But this guy on chapter 20, he has these experiments that are pretty incredible. And what he does is he picks a lot of old patents and he finds old inventors, 100 years, 150-year-old inventors. And then he just pulls out their little tips and tricks. And he has you walk down these experiments. And so I really, this was my inspiration. And so I'm just going to read this real quick. So this work acknowledges the inspiration of R.A. Ford in his book, Homemade Lightning, chapter 20, where he described 3 experiments he called self-contained entities. Ford's focus was on weather phenomena and ball lightning, exploring these ideas in the context of nature. Building on Ford's first concept, this research takes the idea in an entirely new direction. And here we have the RAV, the resonant arc vortex. So what different direction I'm kind of taking this to the next level? Well, I'm going to have a sustained feedback so that these RAVs are pretty much self-sustaining, self-contained sustaining system. And then I'm working on scaling it. So you're going to see how big I get these RAVs in this presentation. And then what's my purpose really, or my goals? I want to have alternative propulsion. I want to research atomic fusion through confined plasma. And then I'm looking for a novel source of energy. And what's my motive of this project? It's simply to help all humanity. And the reason why I did this, it's called an open science license. And all this means is that everybody's free to have fun and use the RAV however they want. They just can't sell it. They can't charge people money. So that's my motive behind this. So as we all are standing on the shoulders of giants, we sit on the shoulders of Tesla quite a bit. I guess I'm gonna step on the shoulder here of the giant R.A. Ford. And so this is kind of the background. And let's get to the presentation. Now, this would have made R.A. Ford pretty happy. He didn't really do anything close to this, but he is very interested in weather phenomena. And as I was testing forming RAVs, you have the clay under here, the water, but this is a ring magnet from a microwave oven, magnetron. And the way this ring magnet is set up is that it sits flat as a pancake. The top is north, the bottom is south, or if you flip it, it's the opposite. But it's pretty fascinating how there are a lot of correlations to how plasma functions in magnetic fields. And the Earth here on the left has its magnetic fields, and it has its type of plasmas, and yet on a much larger scale. And so I guess R.A. Ford wants to introduce ways of kind of understanding weather through these kinds of self-entity plasmas. Now let's get to, I would say, some of the most important experiments regarding the RAV. If these experiments didn't occur in the way that I had hoped they'd occur, I would have just said, you know, it's a bunch of arcs and sparks and big deal. But this is a property that that really got me hooked on it. And so what you're seeing here is a neon vacuum tube, not a vacuum tube as far as electronics, but it's just an evacuated tube of glass filled with neon. Now I'm placing it next to the RAV, and I'm placing its metal portion at the bottom in the water. That's the cathode. Okay. Now this is exactly what I want to show you. If you look at the tube here, there's no energy in it. Yet you have a massively powerful plasma here right next to it. When the plasma was disorganized streamers, it would react with this tube. But when the plasma is confined, and it has to be self-organizing to be confined, this gives it a whole new property because we don't see plasma really do this. I mean, if you look at fusion reactors today, they use a lot of complex machinery to use magnetic fields to control the plasma, to contain the plasma. But yet here we're just balancing elements from nature, and we're seeing that it spins up a self-contained, self-confined plasma to the point where you can have this right next to it, this bulb here, and it actually has zero interaction. So this is one of the biggest reasons why I wanted to pursue this path. And I'll be sharing some more here, also some other reasons. This is where I took the neon tube outside the cathode instead of the water at the bottom of the cathode, and it acts the same way. It lights it up when there's a somewhat chaotic plasma, but then when the RAV forms, look at it. The entire tube is drained of energy because the RAV has pulled it all into itself. So pretty fantastic to me, at least from my opinion. So what I'm going to be doing is kind of walking you through the experiments that I feel like are important, and this one's very important as well. When you're seeing that chaotic purple circle of streamers, it's tough to do this for some reason. There we go. There we go. Okay. When you guys see that the plasma's like this, I put 3 oscope probes around it at 120 degrees apart, and these are the 3 patterns, if you will, the sinusoidal waveforms, which are actually kind of more sawtooth waveforms here. but they're not stable. Yes, they're frequencies, but it's a noisy frequency. But as the RAV finally forms in that, Joe coined the phrase coherence, which I really like. When the RAV, I'm sorry, when the plasma reaches coherence, you'll find that it's a very stable RAV. So check that out. Now, that's when the RAV forms. So here we see this just beautiful organization that occurs from, well, just an ordinary set of materials. So we have this little orbiting ball of plasma, and it's not letting energy escape, and it's forming very clean frequencies or signals. And so this right here, the oscilloscope probe is kind of acting like a capacitor inductor. And so what happens is when you bring it next to, it's basically getting this frequency actually from the cathode. But I'll talk about that more later. But what we're seeing here now is just that there's order. We go from disorder, which is it's chaotic, but chaos does have some kind of order. But we'll just call it chaos, and now it goes to order. I always want to introduce the environment that I'm working in. This is the clay structure, the clay pot. When you're trying to create a RAV and you don't have the correct environment and things just sort of get all wet, this is what happens. So when I'm thinking about, hey, I want to create a RAV, you're kind of seeing me smooth out the wrinkles and get the RAV created. But if everything gets wet and it's not kind of a specific environment, you get this kind of chaos. Just to give you an idea of the power that I'm using that's going into the RAV, it's kind of mind-boggling when you think about it, because that's a lot of energy being spinned up into those balls of plasma. This is the same power supply, same power, but it's not self-contained. It doesn't have the environment to get it spinning clockwise and then spinning up into a RAV. Oh boy, something happened there. Sorry, guys. It just skipped ahead. Here we go. I have some tremors, so I clicked it like 10 times. Here we go. All right. Let's see here. I just reviewed these videos and slides earlier, so I should know what this is doing. Let me see here. Because I'm wanting you guys to see something unique. Okay, so the purpose really of this is I can burn this RAV all day. It's literally easy to self-sustain it now with the right combination, the right recipe. Now, I'm going to start to create RAVs now again in these ring magnets. And I want to show you how important the magnetic field is in creating a RAV. So what now is happening is I could easily create a RAV on the clay here. But now that I've put a ring magnet there and I place the anode in the center, it's trying to form RAVs, but the magnetic field of the ring magnet is disrupting that creation. And so you'll watch it, it'll try to just at its best, I want a RAV, I want to look that, oh, I'm almost a RAV. Look, nah, the magnet just rips it apart. And so this shows me here that the magnetic field is a super big player in these RAVs. Look, it still forms a RAV, but not really. The RAV just can't handle it's overcome by the magnetic fields of this magnet. Now, I'm gonna, what did I just do? Okay, so this is the magnet flipped over. Now, almost immediately, we see the RAV form. Now, because the RAV is running out of the ingredients that sustain a RAV here, because I didn't really set it up that well, you're going to start seeing it break down. But again, the magnetic field is in a different shape, and it not only creates a RAV, but it creates a nice steady RAV, and it's really quite quick actually compared to the other one trying. So what's really holding this rab together? What's the main player in holding it together? It's its own magnetic field, as proven in this experiment. All right, so this was interesting. I discovered where I'm in the vacuum chamber, and we're going to see some more vacuum chamber experiments. But here I have a rig magnet. Now, sorry for its haze, but there's some steam fog going on in my vacuum chamber, so you can't see it too clearly, but you can make out the magnet here. In the middle of the magnet is another type of plasma, self-organizing plasma, which I call the cathodic fireball. It's just a fancy word for a little plasma ball on the anode. I'm sorry, the cathode. This right here around this flat plate here under the magnet, it's actually copper, is the cathode. And so normally you'll see this sort of that spinning ball of chaotic plasma streamers get tighter and tighter until it forms. And we'll see that in a little bit. Even with this cathodic fireball or the C.A.F, C-A-F, it's reversed. So, and the chaos is not down here forming, the magnet won't have it. The magnet's saying, nope, I'm going to pinpoint this plasma here, and whatever you want to do, you can do it up here. so, so the plasma sort of has to be disruptive here, right on the anode here, if you can see on the right. It has sort of this, okay, we're going to try to figure this out based on all of the environmental variables. But the magnet's saying, nope, I'm keeping the plasma where it's at. And this C.A.F has similarities to the RAV, but it's not enough for me to say it's a kind of rab. It's actually a really different animal. Let's see here. Sorry about that. I think I'm going to try to show you the video of that. See here. Yeah. So this is the video of what I took the snapshot of. Sorry for the camera angle. I'm trying to figure out how to measure, or I'm sorry, distance and get the camera working. So in the middle here, this is the top view now of the camera. In the last photograph, you were seeing this on the side like this. Now I'm adding more and more voltage, and what's happening here is this C.A.F is growing and growing and growing, but you'll see that there's no real chaos going on in here. And that has to do, again, with the magnetic field really keeping it in this shape. But in order, because the variables are changing in here, we get that reverse. So no chaos here on the cathode, but on the anode here, in order to sort of meet the requirements of this environment for the magnet, it starts getting disrupted. And it's saying, hey, I gotta try to figure this out. The magnet's like, nope, it's gonna keep it a sphere. Now, this is where, interesting, a question mark arrived in my head regarding this. Okay, that was a bad joke, but interesting shape here, like a question mark. But seriously, I just kind of wanted to again reemphasize that we've always known magnetism affects plasma. That's what it is in a TV set, in the cathode ray tube, or the CRT, what we used to call them, where you just have a beam of electrons heading toward the phosphorescent screen, and the electromagnetic control would move that electron beam, and we would get our TV set video. And so I thought I would share that. Here's another phenomenon that I think is important to understand about the RAV, is that there's something going on top, but there's something going on at the bottom as well. At first, it kind of looks like there's not, but the gaps I've stacked between these clays, you can definitely see that there's some action going on under here. And I'll show you some cool things that what the plasma does under here later, but this is, I guess, an important aspect to help us understand the RAV better. And that is that it's not just the top side clay phenomenon. And I know Nathan and Joe have some pretty cool videos that prove this as well. And I just want to maybe just take a step back real quick and say that Joe and Nathan have been really digging deep into the RAV and providing some really keen insight into understanding this phenomenon. And so I really appreciate their help. I want to thank them for that, as well as kind of share with you guys that Nathan, Joe, and I are kind of a team here now. And then we have two outside consultants. I like to call us the Council of Five. And so we have consultants, Brent Jarvis and Ian. Oh boy, I'm sorry, Ian. I should know your last name. I feel terrible. But everybody knows Ian. They're outside consultants that we kind of get sanity checks from our experiments, while Nathan, Joe, and I are digging deep. All right, so let's get back to this. So what fascinates me about these markings in the clay is that the rab jumps. The rab just sort of takes off, and then builds on parts of clay. And one of the things that interests me about this is that if it can jump off the clay and it's still in its organized form, maybe I can keep it in that jump state. Sounds like a reach, but this is why this pattern interested me. So I found a salt lamp at a thrift store. I cut it on my bandsaw. And if you ever really want to know the best way to dull your bandsaw blade, cut Himalayan salt like this. My blade is worthless. So I'm looking for different materials to create the rav. It's important to me because, for example, this salt here, and this is a pretty flat piece, even though it doesn't look it, because it has these transparent zones from the salt minerals. But what happens is the different kind of porous materials, they have different rav effects. And I feel like if we study different rav effects, well, it'll help us narrow down what the rav is doing, and lead us down a road really to those higher goals of, like I mentioned earlier, alternative propulsion, fusion, plasma containment. Here we go. That's the rav right there. Okay, there's the rav again. You can always tell the rav when it's, there we go, when it stops. And now if you're in the room here, it's quiet. It's another thing. You'll hear this little hiss, but when the rav forms, it's quiet. If it's not quiet, it's sort of kind of in that I'm a frustrated rav state. But when it's in total coherence, it's completely quiet. So I'm working on salt because I think salt, this has so little moisture in it. I put like 1 drop. If I can form ravs with literally almost no water, I throw this into a more environment that sustains it. Look at that. That was a good long rav. I think that then there's we're going to be able to get that large plasma self-contained sphere that might link us to fusion, for example. Look at that. It's just beautiful. That's really stopped now to be a really good solid rav on the salt. And this is not a great piece of salt. Now, granite's another thing I'm really wanting to dig into. This is what you can buy off Amazon, and they use it for making jewelry. It's a very, very flat piece of granite. And what I do here is I just soaked it in water for a few hours, and then because it's porous, I wanted to see if it can create ravs, and boom, it creates a rav. Yeah, it's super dinky, but I'm just understanding granite. But I just want to share with you that it's another possibility that can aid the rav. Let's say I have 5 different materials that help me see all the pluses and minuses of the rav. Maybe take that into account to create the perfect rav. It's kind of my thinking there. Here's a cool thing about granite. Granite is so the plasma from the anode is like a probe, and it's probing all of the minerals and all of the mechanical structures inside the granite. And so if you want a map of the inside of the surface of the granite, you're kind of looking at it here. So I thought that was kind of a cool view. And look at that. We're getting some ravs on the granite. Pretty awesome. Again, there's some differences in the granite. Look at these little tiny feeder guys. Let's see if I can pause it here. You can see that these these are little cavernous channels. Plasma goes in, and they look like little stars. So plasma comes in from the anode, really doesn't. It starts the opposite, but that's confusing. Just kind of pretend, but it helps you understand it better. These little guys are filled with plasma within the structures, and then these little guys feed into here, into creating the rav. And so it's pretty interesting how it does that. I think there's actually a better, there we go. So these guys are just kind of, hey, we want to aid in your construction here because granites just form pretty cool. And so what I want to do is I want to sand the rough side and then keep the smooth side because I want to kind of see the natural granite versus this smooth granite, even though the smooth granite is pretty cool. I think this is another granite. Probably can skip it. I tried to shorten this presentation because I haven't seen you guys in so long. I have so much to share. And I've missed you guys. So it's really great to be here. Here's a unique characteristic of the rab. It likes to dig circles to kind of represent the reaction with. There's a chemical reaction going on here, and it's forming. You know, we see it forming in spheres, but here we go. If you put a sphere in a two-dimensional form, it's the circle. So fascinating. Here I bought this brick. It's really nice. They actually build saunas with this. It's a salt brick. So I'm going to really smooth it out. And I'm just going to put the tiniest amount of water, dab of water, and see if I can just get a large rav working on this. This looks really promising to me. Okay, so you guys have seen this before, but I wanted to explain it better since I know a little bit more about these. Uh, I poured bismuth powder. This is all bismuth powder. And now the plasma enters into the bismuth powder and it starts to melt, but starts to draw it in because the powder was pretty scattered, but it draws it in. Plasma is heating it up, melting and drawing it in. We can kind of see this little formation right here. And it's a torus, which is kind of fascinating. Now it has something going on in the middle here. But this is actually forming the bismuth from the powder. And as it organizes the rav, it organizes the bismuth. And bismuth has some pretty cool properties. There we go. See, the rav just sits it's like a cradle for the rav, that little bismuth donut looking thing. And we see it. And what's interesting to now is the bismuth is heating up and it's spawning another rav. So again, different materials, different compositions, different factors, elements, and cool results. It's pretty fun to watch. So bismuth is on my list. Look at that. I'll call this the bismuth rav. And look at that. It's incredible. Here are some of the materials that I bought off the internet that I'll be experimenting with. Toscano, it's a Spanish kind of stone. Tierra, I actually do some experiments with that, so I'll show you a little bit. This is called the Super Satillo. And what I'm doing here is I'm trying to cover the whole range. I don't want to buy every in-between type of brick and clay. And I just wanted to get the range. So you kind of see that. Then you get this Tierra, which is a dark reddish, see probably a lot of oxidized iron in there. And then you have this really, really bright Satillo, which has a different composition, a different rock that it's evading me at the moment. It's the yellow that you see in bricks in Milwaukee. Milwaukee, they call sometimes the Yellow City. It's because they use this yellow brick, and I forget now what it is. It's a different kind of clay. Also, too, I was looking, how do I get limestone at a cheap price and then flat? And then how do I get sandstone at a cheap price and it's flat? Well, they make coasters out of them. So I don't have to do any work sanding or cutting. I got these nice coasters, but yet I'll get to run RAV experiments. Sandstone's going to be fascinating because it's silica, it's sand, it's glass. That'll be really fascinating. And then the limestone is, it kind of threw me off with limestone being a kind of porous rock, but it is. So, and I didn't know they made coasters out of it. And the reason why they pick these types of rocks for coasters is because they are absorbent of moisture. So they've already done all the work of making this a material that's porous to interact with water, already done for me, because they do it in a way where you put your glass of beer on here or bottle of beer, and it absorbs all the moisture from the condensation. So that's going to be an interesting effect to try. So this is some of the stuff I'm playing with, deepening my understanding of the wrap. This is the Tierra. This is pretty interesting because it didn't have any of that purple action. It just goes right to a RAV. This is like the RAV material. If you're pulling your hair out trying to create a RAV on red clay pottery, yeah, this Tierra is it. I'm telling you. And the RAV is very unique too, on the Tierra, because it doesn't create that carbon, that black edged carbon that we're used to. No, it seems like this Tierra just feeds its minerals and feeds it this fuel, so it doesn't burn or etch or carbonize. Or maybe it's just a different chemical reaction that doesn't carbonize, because what you're going to happen to see, look at that, there's no waste and no leakage. It's totally insane. Maybe I'll change this to the RAV stone. You can see here there's no black carbon. There's no etching actually. The surface is only just bleached out. It's there's no really of any of the effects that we've seen in any of the other clays. This is literally the RAV clay. So this is repetitive, and I know some of my slides are repetitive in videos, but I kind of want to just cover different aspects again, just to kind of drill in what's going on, what I'm doing. We have that signature, beautiful clockwise spinning purple plasma, then boom, forms that really pretty RAV that we're used to. This is on the red clay. So we're used to this. Again, just getting the right moisture top and bottom just to get it kick-started. And yeah, we get that beautiful RAV. I think what we're going to see here is the frequency on the oscilloscope here in a moment. I've been sort of taking a lot longer videos. I hope it helps you guys kind of get a little bit better view of it. And there we go. So the coherent RAV, this is one oscilloscope probe, not three. And you're getting this beautiful 3 frequencies. I've actually documented those 3 frequencies, and the reason why there's 3 frequencies right now that I can guess from my research is, oh boy, is that like the sun, if you can imagine the sun here, there's the North Pole and the South Pole, and then there's the equator in the middle. And so what's happening is that the higher frequencies are at the poles, top and bottom, and then there's a slower frequency in the middle. And I think I got that right. I'm dyslexic, so it might be the reverse. But I wanted to show you that frequency, because it may look like one frequency, but it's actually not. It's 3. It just has the same amplitude because the electromagnetism that's leaving it has this changing frequencies, but it doesn't change in amplitude. Now, in a little bit, we're going to look at my photodiode meter piece of equipment, and the photodiode is going to see the amplitudes. And so we'll see that in a little bit here. So let's go upside down with the RAV. You guys have seen this before, but I kind of want to point out, does gravity going to have like an effect on the RAV? This is kind of a little easy way to check it. I think gravity has a little bit of effect because when you watch the feeder from the anode to the cathode, it's quite thicker. It's almost like the RAV forms, but the gravity kind of pushes plasma down to the anode. It just kind of looks like that. So yeah, gravity does have an effect on the RAV because again, it's just pulling down and the anode feed is just thicker. And the RAV has a little bit of different kind of shape. It's almost kind of looks like a little Saturn shape, or maybe a little UFO shape, just to kind of give you the shape, but not matching it with UFOs. So this is the upside down. This is a kind of cooler picture. where a lot of cool stuff's going on the bottom as well as on the top. So the RAV works best on flat surfaces, but you can make it work on rounder surfaces. This is a little bit rounded, but this kind of makes the point that there's a whole lot more going on under there than just sparks on top of a piece of clay. And we'll take a look at these in a little bit. All right, so let's get to the gas, not the gas chamber, the vacuum chamber that I have. I picked this up from Vevor, VEVOR. This is a copper strip. I run some plasma experiments in here, and the plasma changed and oxidized the copper strip. And the copper strip's the cathode. And so I wanted to point that out because instead of clay, I have copper. Instead of water in the clay, I just have oxidizing copper. And so there's some similarities there. When the RAV heats up the clay, the resistance changes because the water is evaporating, and it's just sort of this dynamic change in the conduction of electricity or the resistance to the electricity. The same thing's going on here. So as the oxide forms on the copper, the resistance value changes. So copper, you would have 1 ohm on a clean piece of copper, or 0 ohms. But here on that oxidized copper, it's 300 kilo ohms, it's 50 kilo ohms, and it's this dynamic resistance that is part of creating the RAV that you're seeing here. But this is not a RAV. I'm going to call it that C.A.F, C-A-F again, the cathodic fireball. Now you can see here that I'm creating, this is what the cathodic fireball leaves behind on copper. And so I kind of wanted to give you a little bit dig in here, as well as give you a clear picture of what I'm doing here. So if you want to take a screenshot of this, you can see that Vevor, VEVOR. You can get this on Amazon too. It's a little kit, and $160, I think. It's not cheap. It's not expensive, I guess. But I just ran some copper tape down it, and the lid seals quite nicely. And I'm able to get some pretty serious vacuums in here. All right, so this is what I call, again, the C.A.F. C.A.F has its own kind of properties. The C.A.F is almost cylindrical. I would say it goes from, not cylindrical, spherical. It's definitely spherical, but it kind of goes toroid and spherical, and yeah, it's moving like a crazy man. It's almost like a RAV in 10x speed. You know, you can see the anode here. It has this beautiful fluffy stream here of electrons. I love it. I love plasma in vacuum chambers. I don't know why. It's just fun to me. Now, so you see this little guy, and it's spinning. It has a frequency. From what I can tell, it's usually we're getting 100 kilohertz range frequencies. This frequency here for this little guy is about 50 kilohertz. So it's kind of cut in half. I haven't figured out why yet. I think Nathan has a good theory on that one. But this is what we're looking at. The anode here is on the left. I'm trying to create a RAV just like normal, but I don't have the clay yet. And so boom, there's this sort of object that is self-confined, self-organizing, strange, but awesome. I'm going to kind of give you guys different angles. This is the top angle. So I put Kapton tape on each side of the copper tape, sorry, because electrons like sharp edges, and I give it no sharp edges. If you don't get rid of the sharp edges with the Kapton tape, you will not get this formation here. You won't get this plasma. So love it. I'm loving my self-organized plasmas. It's fun. I'll say sorry, that was selfish, our self-organizing plasmas. Now, this plasma is kind of a interesting character because the RAV runs up and down on this strip here, but yet all the heat is on the sides. It's almost like it's a cold plasma. There's probably some thermodynamics going on here, but what's happening when I pull this out here, the copper is cool to touch, um, except where the calf is. Wherever the calf is, it's cool, but wherever the calf is not, it's hot. Again, just probably just give you some more different angles of the calf so we can kind of learn how it acts. Let's see, what's this one? I might have a double here. I hope not. Yeah, sorry, this is a duplicate. Here we go. I put in a piece of solder because since this calf likes to kind of develop on metals, and I thought, well, let me research these metals. So this is just a piece of solder. Calf loves it. Calf is devouring it. It's just eating it up, and it causes those really cool flashes. And also, look at that. So it's the path of least resistance is not the copper, the bare copper. It's actually this piece of solder that it's devouring. So pretty interesting. This is a side view. Good idea, Nathan. He says, hey, get a side view of the calf. This is where you're getting more of that toroidal shape. It definitely is a three-dimensional object. It's not like shining a flashlight on a piece of metal. You have this beautiful anode on the top. I mean, this beautiful stream from the anode, and here it's coming down. Oh, and for your information, guys, the vacuum pressures I'm working with are down to about 17% of an atmosphere. So atmosphere is 100%. This goes as high as about 17% of an atmosphere. So there's all kinds of different ways to measure the oh boy, the vacuum. And I just wanted percentages because it's complicated. So here's the interference pattern of the calf. So it likes to draw these interesting characters. They look like Sanskrit or something on this. This is polished copper. I did put an anode that was a sphere. And what's fascinating about the anode with the sphere is that the sphere balances the plasma to ensure that the calf just has this beautiful little cylindrical shape. And so that's, I don't know why that is. It seems like this anode is forming a copy of itself because it just doesn't want to move. And at different angles, it doesn't look like a perfect sphere, but at other angles, it's a three-dimensional sphere. I put a little aluminum dessert cup in here, and it just likes to draw Sanskrit right there. I don't know what it is. But it's just, I thought it was interesting to share, guys. I'm using the sphere here as the anode. Dropping down the bottom here is the cathode. You can see the copper coming down here. So the copper strip is conducting the making this aluminum act as a cathode. And it's really fascinating. It just wants to paint the whole side. It's kind of interesting. And I've watched it go around and around. So look at that. It's pretty interesting stuff. It's more just play stuff, less scientific. So this is, let me see. Okay, so this is inside the bowl or the aluminum shape, but for some reason it stopped here, and it's just feeding into this spot here. The copper might be just most conductive under it. This might have the least resistance area. And once it finds it, it's got this sort of rhythmic movement to sort of keep this calf perfectly cylindrical. I keep saying that. Spherical, perfectly spherical. Now, when we talk about the purple chaos before the formation of the RAV, the calf has the white chaos before the calf. Now, when the RAV moves around, it's etching out its channels. I like that word, Joe, channels. Nathan came up with it. But you have this erratic sort of motion until finally it self-organizes. And when it self-organizes, you cannot say this is not self-organized. but it starts to cut paths like almost like on a skating rink. And this, oh, by the way, this is not aluminum. This is bismuth. Sorry, I should have introduced that. This is bismuth. And bismuth is a nice substrate as a cathode in order to create really nice three-dimensional cathodic fireballs. And then there's some interesting stuff in the paths that it makes, which we'll take a look at here in a little bit. One of the things I noticed too is that there seems to be at different pressures with the materials I'm working with, sometimes it just changes the hue. I don't know where this is coming from. I don't know if maybe bismuth is emitting a gas that in the vacuum chamber with plasma, it just gets more blue. But I thought I'd just kind of show this to you. This is just, again, the cathode here, I'm sorry, the anode here feeding into the cathode. This is a body, it looks like the surface of the moon, but this is a disk of bismuth. And this little calf is just bouncing around. It releases some kind of gas and boom, everything goes blue. It's not a camera effect because I've tested it multiple times. It just happens to be when there's a certain particular moment. Another side view, it's just perfectly running along, polishing the surface, like kind of like a vacuum cleaner. The calf here, and it's a closer look. It's eye level with it, so again, not the perfect sphere, more toroidal, or a fat donut, but at different angles it looks spherical. So this was when I was able to create a better one. It's kind of what I don't want to share it with you guys. All right, here's the calf again. It's cutting paths into the bismuth, and it goes chaotic like a rev. Then it self-organizes and combines, and just like the rev sort of needs something from the clay, maybe minerals, this calf needs either from the aluminum, the copper. Here it's bismuth. It has this sort of reaction. And I just tested these metals because they were laying around. I tend to just go by intuition in all of my experiments. I'm the accidental, I think, the accidental engineer, or the lucky fringe inventor. So you can see with the light here, I'll show you that one here. You can see with the light that this is the disc of bismuth. Okay, all I did is melted it into one of those aluminum things. I just put it on a pan on the burner in my kitchen. I melted the bismuth into that aluminum little dish, and then it made this sort of rough, pitted bismuth surface. And so I wanted to see it in the daylight because it's kind of hard to see in the darker images. And yep, again, goes right into self-organization. And pretty cool stuff. I'm adding vacuum, I'm adding volts. I go up from between 10,000 volts, which is the lowest setting, to 30,000 volts. It's DC. And also I'm changing the vacuum pressures in order to really lock in, because there's an environment here that requires variables. It's not something that you just throw it all in and do. You have to kind of just play with the variables until you figure it out. Here's that's cool Sanskrit or ancient Egyptian shapes. What's fascinating is if I stop some of those shapes, it's pretty fascinating. One of the shapes is actually a swastika, so it's probably not a good shape it makes, but it's interesting. See, that was kind of, it started with that kind of, let's see here, where are you? Kind of started with that. There you go. Maybe I'm looking too much into it, but these, if you play around and freeze them, you start getting really clear shapes. And so a little bit of close up, bismuth, and another cathodic fireball. Doesn't really roll off the tongue. Maybe I'll have to change it. This is another view of it. It's trying to pick, is the copper more conductive? Is the bismuth more conductive? I'm turning up the vacuum. I'm turning down the voltage. You can always tell when I'm turning down the voltage because there's less of a plasma feeding the calf. But you can see it jumping. I love that jumping action. And it doesn't lose its shape when it jumps, so it's like a RAV. When I reduce the voltage to a minimum, this pretty much goes dark. I think I have a video of it. It kind of looks like the calf has just formed itself. There we go. So this is not the purple spazzy chaos we're used to for the RAV. It has its own white. Now the bismuth did something weird here. The bismuth started putting out some different gases. I don't know, but the colors just started getting really pretty. These colors are much prettier in person. Camera kind of doesn't do justice. But another thing I notice here is that it's not doing the ice skating on the smooth bismuth. It's digging a hole here. And I'll show you what it looks like when it's done. But it's a circle again. Remember when it carved the circle in the salt? This is carving a circle in the bismuth. Again, we have this somewhat chaotic beginning. And then I just kind of want to show it to you again. It says, I'm digging in here. I'm going to let out some cool emissions. And then I'm going to start digging a hole. And not a hole, but I don't know. It's etching in its form of a sphere like the salt was. Look at that. It's just kind of painting that circle in like a hot paintbrush there and over molten metal. And pretty cool stuff. See. Oh, this was interesting. I use a silver wire, same thickness pretty much as the copper wire. Copper wire never moved. Silver wire moves. Not sure why. You get different hues. So on top here, this invisible part here is the anode. It's silver coming down from the top here. You can almost see it, but it does this weird, almost looks like a little tornado thing going on here. So again, the anode's on the top here. It's silver wire, 99.9% silver. Magnet wire comes down and it forms this plasma stream that feeds the calf below, but it has this kind of action that you don't see in the copper. Copper doesn't move. Silver moves. So I think Ian had a good theory where since there are more free electrons, it's causing more of these plasma bursts, and the wire is just too thin, can't take it. Copper doesn't have it because copper has less free electrons. I think it's a pretty good theory. Also, it's just kind of cool to look at. Again, this is happening in a vacuum chamber, so this is not outside. So this was what it looked like when it was burning that circle, that hole. And you can see that, and you can't really see it really well, but these are all little spherical nodules of bismuth that were formed by the plasma. They're not spatter, which I thought they were, because they're kind of almost formed from the bottom up versus the top down. So it's not spatter, which really is kind of interesting. I don't know what to do with that, but it gets blurry, but there you go. You can kind of see it. So this is different. This is more acting like a RAV where it's creating channels for the calf. Let's see here. All right, so this is the bismuth disc that I made. And this helps you kind of see it better. I probably should have shown this before all the other videos. I apologize for that. All right, so now it's time to create the RAV in the vacuum chamber. We've done a lot of calves. Now let's do some RAVs. Now I'll say that this is the terracotta, the stuff we've been all using together pretty much. It's just a clay pot I got from my wife's plant pot, and has a little bit of moisture. The anode, the cathode below here is that aluminum tin that sits on the on top of the copper here that goes out. This is the cathode. This top wire that's coming down, we're back to the copper. This is a thicker copper wire I switched to. I didn't want copper moving at all, so I just went with the thicker here. And we've got the moisture, we've got the vacuum. I turn the voltage on and the vacuum at the same time, so you're kind of getting this effect. Now, it starts to get foggier, as you notice, and then it just turns into this blue chaos. And I'm looking for a RAV here. There's a C.A.F. Don't want a C.A.F. I want a RAV. You can kind of see it. And so I'm letting you see this kind of what I call the failure, because I do the guess and check method. Guess and check. And I use my intuition, guess and check. That's my scientific method. So that's really a failure. I think this is a failure too, but this one kind of has something cool you'll see here in a little bit. It's these dancing calves. They're perfectly spherical when they hit the cathode down here, which is that aluminum plate. And but I don't want this. I want a RAV. so all in desired effects. I'm learning. And there we go, the dancing calves. Then it turns into that blue haze. This is torture right here. This means you're dead in the water. Get a new piece of clay, dry it out, because it's a failure. All right, look at that. I've got a RAV. My first RAV in the vacuum chamber was before this. This is my second. Now, when you see it thick right here, it's C.A.F., then it's half C.A.F., half RAV. This is all RAV right here. And you'll sort of see this sort of back and forth. Now, you can already tell the difference, that there's something, there's noticeably something different from this. And one of the things is that it has these little lines of plasma shooting out of these thick lines. Secondly, of course, the anode's feeding something a little bit more spread out, because the vacuum lets the electrons space out better. And yet we're etching into the clay, and we have a RAV here. And wow, how awesome is this? As I'm doing this, I'm excited. I want to grow this thing. And then I start hearing my vacuum pump start sounding like a choo-choo train going uphill. And it started losing pressure. And I thought, oh no. I looked it up. Water's getting into my nice, beautiful vacuum pump. It's not sealing right. So you're going to see some radical vacuum changes, which I think is why these are a little bit more erratic. But I still use it. I'm just going to change the oil. Nathan had a really good idea. I think it's Joe, where I'm going to use a water separator filter. I just didn't know enough about this, and I hope I didn't destroy my vacuum pump. But so moving forward on these RAV experiments, just know that the vacuum's good, but it's not consistent. And so here's another RAV in a vacuum on the clay, anode on top. This is the top view, and you're seeing the stream of electrons come down. These RAVs are way brighter, way bigger than I'm used to. We're going to keep seeing these guys grow, and yet I'm starting to hear my poor vacuum pump chug and choke, and I want it to get bigger, but I have to turn it off. Here we go. We're going to try it again. But I think you'll find some of this cool stuff. So you saw a C.A.F. there. Now it's a RAV, if you missed it. And you're probably wondering, well, how can a C.A.F. form on clay? But it actually does. I think it has a higher moisture content, which does that. And so we see here, again, when you have these flashes, and I'm going to show you in a little bit, some of them are just flashes of light, but some of these are actually large formed spherical RAVs. And so I wanted to kind of show you like this. Like, this is not light. This is a RAV, okay? And it's larger than I'm used to. And it's going to get bigger here if this is the right video. So watch it. See, has these streaks. That's probably from the vacuum. The magnetic field that it's creating is holding it together and balanced with the electric field. Yet because you're losing pressure, It allows this to spread. I'll leave it to Nathan and Joe. They can explain these on their deep dives. They have a really great presentation. Maybe Joe could share it. Nathan can share it in the chat. But it's just, I love it. I love it. Yeah, there's flashes, but there's also big ravs in here. I don't know if this is the video though where I have the biggest one. So that was I mean, no, I don't want that. Let me see just one thing real quick. Let's see here. We can, there we go. So these aren't flashes, okay? These, because they're cylindrical still. My camera's not fast enough to take a slice into a flash forming. So when you see a flash, it really is a flash. It's not, when you see the cylindrical form here, and it's way more cylindrical when you're looking at it, because this is camera's at the angle. I'm more at the side, other side of the top. And this is a sphere. You just can't get away from it. It's a sphere. And my goal was a golf ball size RAV. I haven't gotten there yet. I think Nathan said this one's a 3/4 of an inch, I think. He has some really cool way to measure it, which I hope he shows you guys after this presentation. Oh boy, we're going long. How many slides do I have left? Yeah, guys, apologies for that. We're going to be almost done here. I'm just talking too much. This one's interesting because you'll see at the top here, the anode, it's gas in my, with so much steam. And this is where I get my theory about the water playing a bigger role. Because you can see here that, look at that, that's a RAV. It's huge. There we go. Look at that RAV. I think this is the one that Nathan measured to be 3/4 of an inch, and I think that's probably the biggest. But Nathan said he can build them bigger. I hope he can. That'd be awesome. Now, what was creating these bigger ones? What was really getting these spheres to come out was just add a little more moisture. In the vacuum, there's very little air molecules to ionize. So, and Joe gets credit for this. There's an electrolysis going on where it's splitting the water molecules into hydrogen and oxygen. And that's what's really feeding here, is that hydrogen and oxygen that's getting ionized, that's being produced from the water through electrolysis. Now, you can tell that I'm adding more water here because it's super foggier. And again, my poor pump, it starts chugging, and then we're done. So I think that's the biggest one. I'm on track, I hope, to get my golf ball size RAV, and then I'm going to go for a basketball size. Why not? I think we'll learn more and more as we do it. So the anode here is kind of showing some leakage here. If you see that dropping down from the top. Look, filling with steam. My pump's upset. And so we're seeing C.A.F like activity here, not RAV. And now there's a RAV. So you can kind of see the difference between the two. And the higher the vacuum, the more dominant the RAV. Here we go again. There's just these they're like pulsars, these high energy RAVs. And this is the vacuum increasing, the voltage is increasing, and it's just tearing up that clay. But look at all the moisture, look at all the fog. These are water vapors, and my pump hates them. So but I kept doing it because I wanted to have some cool videos for you guys. Super cool. All right, we're going to take a look just at a couple more things and we'll be done. So this was that red clay that was making the RAVs inside the gas chamber. All right, so this kind of looks familiar, what we're used to. I said gas chamber. Oh, sorry, guys. The vacuum chamber. it looks similar on top than out in the atmosphere. But look at the back. I can't do it. In the back of the clay, it's forming fractals. It's almost artistic. I've not seen this in any of my RAV experiments, but for some reason, clay RAVs in the vacuum chamber carve beautiful lines, and it even colors them. They're three-dimensional. It's really fascinating. This surprised me. I don't know what to say about it. Maybe I'll ask you guys in the chat. Maybe Joe and Nathan have some great theories. But I thought that was fun. Here's a close-up. Now, I would use it, take a picture, use it, take a picture. So it's actually taken on different shadings and different lines. But this is, I guess this is as close as I can get it. Wow. I mean, if I put this on, hung this up on a wall, people would go, "Oh, that's abstract art." I'm like, yeah. Or I think it's called non-objective art. No, it's abstract because these look like trees. So I've created this little chart from the right to the left. We're losing atmosphere. On the right here, we have as low as 83% atmosphere. Streamers plus flash RAVs, you're getting all this chaos. When you get down about as low as 50% atmosphere, 83 to 50%, you get this RAV C.A.F competition. Had I slowed some of those videos down, you would have seen the RAV and C.A.F battles. But for the sake of time, I kind of want to move through this. I don't want to keep you guys too long. RAV becomes dominant here when you get into the 50% no atmosphere to 33% atmosphere. And then over the left, I mean, I go down as low as 10% atmosphere, and that's when you really see zero C.A.Fs, zero cathodic fireballs. RAV dominates. And this is opposite what I would expect. And again, this shows the self-sustainability of the RAV. It's really using the water vapor, it's using the minerals, and it's creating its own environment. That's all, because there's no atmosphere saying you're going to go this way or that way. And if, as you saw, they look like RAVs, but they're a little higher energy, but they're still RAVs. Now I created this thing called the photon harp, and so it's just 3 slits in a disc, and I put 3 diodes. It looks, see the slits I put in the CD-ROMs that we used to put in our computers. And I create this ugly looking device, 9-volt battery, hot glue. There's a photodiode coming on each side. And so why do I have the 9-volt battery? It's to reverse bias the diodes. If you reverse bias the diodes, then they're more sensitive to light. Now they're photodiodes, which means they're very sensitive to light. But if you use them wrong, if you use them backwards, they're more sensitive to light. So Nathan loves when I use diodes backwards. But this is what the thing looks like. These green sticking out parts are where the circuitry of the resistors and the photodiodes reside under. These wires here are for the 3 oscilloscopes. So the oscilloscopes are receiving signals from each photodiode for each oscilloscope probe. And this is going to measure the light. Okay, this is going to measure what's going on, not the electromagnetic radiation when we use the oscilloscope probe kind of dangling. This is reading the light. So now people say, well, light is electromagnetic radiation. Yes, but I want to separate the two because it's confusing. So we're measuring light here. In my research, if I have those 3 photodiodes, I need to have 3 waves out of phase of each other, okay? If I get this bottom here where all 3 waves are the same, then you can read it here, it's not rotating. And so that would have bummed me out because I really believed it was rotating, but I couldn't prove it. And of course, now you could ask, well, what if it wasn't rotating? Well, then it'd be oscillating. Oscillating is just back and forth. But I guess that just wasn't as sexy as rotating. I like rotating, and I felt like that made it more significant. And so I run it and look at this. Beautiful, beautiful. 3 waves. They're not on top of each other. They're not as out of phase. Sorry, my mouse is. This is perfection. This is the ideal, but this is real. You know, the difference between the real and the ideal. And this bottom line, this X line is time. And so you can see here that the yellow sine wave, it ends here in time. This right here, this, let's say minute 1. And then here, this purple comes down minute 2. And then this blue one comes down to minute 3. So they're out of phase. And again, it's not that beautiful ideal. If this was beautifully out of phase, then it would be suspect. When I was a data architect, there's a saying where all data are, oh boy, I forgot it now. All data are dirty. And the reason why we say that as data architects is because if you get a perfectly sweet, perfect signal like this, you know the data are wrong. So, the fact that it came out imperfect means it actually is rotating. And it's rotating, it's saying 101 kilohertz here, but I actually dialed that in a little bit tighter, and it's actually 1 kilohertz. Now, here's some things I do. Nathan has done it better, but I'll put the anode on top here and say it's 1 millimeter wide. And then I draw these 1 millimeter lines imperfectly, of course. And I can say, hey, this is 13 millimeters. Now, it depends on the thickness of the anode. So this is 1 centimeter to 1.3 centimeters. This is a good size RAV, and this is on the salt. So I really believe there's a good future in salt RAVs. But this is just a little tricks I do because it's tough to measure. And so I want everything intuition when I start. I want everything simple. I can't work with complexity. I'm dyslexic. If you buy these little acrylic tubes, you buy 13 resistors, you can have a 30,000 volt probe. If you put a little bit of epoxy in there, and you have a wire on each end, because the wire goes through. See the resistors? They're helical, and so I can now use this and measure high voltage up to 30,000 volts with any multimeter. So here on the right here, you have a standard multimeter that reads up to 600 volts, AC or DC. If you use this 13 resistors in acrylic, epoxy, you can measure 30,000 volts on this one. There's a cheapy meter on Amazon, and Ian pointed me to it. It measures up to 2,000 volts, which you can't really see here, which allows you to, if I do the math, I think it's 100,000 volts. So with this cheapy meter and this cheapy probe, I can measure 100,000 volts pretty accurately, enough for our experiments. And all you need is these little 13 resistors and some epoxy. I picked up this little cool Klein tool where you can get microamps while putting the wire through the clamp here. So I'm trying to measure very faint amperatures, and I don't want to become part of the circuit. This cool little gadget helps me do that. And so I just kind of want to end it on how it's the biggest RAV I've made yet. I'm so excited. It tries to split into 3 RAVs, but boom, that's the biggest RAV that I've ever created so far. And that's the end of my presentation. Thank you, guys. Wow. I went over time, but I hope you guys are interested. And I look forward to your questions.
Dude, that's so cool, Shawn.
Did you learn anything? I hope it was interesting.
Yeah, it was. Yeah, you were getting pretty big RAVs out of there, man.
Appreciate it. Thank you. Did you see any questions in the comments?
They were asking earlier, but I know you explained it a couple of times. Just go over it one more time. The C.A.F, what that means, and then the RAV.
Okay, yes. So the RAV uses clay and moisture. Thank you, John. Thank you, Jan. Thank you, Omega. Thank you, guys. Thank you, Crypto. Darren, you're awesome. Darren, special credit to you. You're
Right on,
donating
brother.
to the
Thank you,
cause.
Darren.
You're the man, Darren. So when you have clay, you have water.
I was just
You
saying
have,
what the abbreviation means, Sean.
oh, sorry. Okay. RAV is resonant arc vortex.
There you
resonant
go.
arc, resonant arc vortex. The CAF is cathodic fireball. C.A.F. Cathodic fireball. Oh, thank you guys. Wow, appreciate it. Wow, you guys are awesome. I'm glad you learned. Wow, I'm glad you're excited about it. I hope you guys maybe want to take this learning into a new level. That would be incredible. Love to see it.
Well, what's really cool is because you're showing like every effect with high voltage that you know what I mean in
Yeah,
different stages, and all you're doing is changing your environment.
right.
You know what I mean? You change how much air is in there. You change the pressure in it. You know what I mean? As you're
Yeah,
going through these, every time that you do, we're relating it to what we're seeing in nature all the time. So we say, okay,
yeah,
a lot of people in the comments say a plasmoid. We're seeing a little bit of ball lightning in it. We're seeing a little bit of just plasma organization in it, and
yeah,
then obviously we're seeing what is it fusion a little bit. You know what I mean?
yeah, yeah. I
But
agree.
all of them are anode cathode effects, and they all
Yeah,
built up because high voltage builds this way.
yeah. And I wanted to stay with the same materials. I just wanted to put, like you said, shift the environment, throw a magnet in there. Um, the magnet is what helped me understand the magnetic field better because it either fought against the RAV as you saw, or it helped the RAV, which means the RAV is a magnetic field animal. I mean, it just is.
Well, the center of the magnet is the what do they call it? The node.
In the ring magnet, it's the null actually
Yeah.
in a ring.
Okay.
Yep, it's a null.
So let's just get this right. So the Rav likes to build in the null zone of the magnet.
Yep,
That's
exactly.
significant in itself. Not
Yep,
like on the sides of it, not outside of it, but right in the center of it.
yep, exactly.
I think there's a relationship we should keep in our heads for later on for why that
Yep.
is.
Yeah, I'm gonna write that down. Such a good idea. I don't remember the north and south, guys. I'm so sorry. Because people were asking, was it the north or the south side of the magnet where the RAV was formed? Um, so the RAV is sort of a polarized animal too, or a dipole-oriented animal, because it either works with the magnet or doesn't. It either loves the magnet or hates the magnet, or vice versa. The magnet hates the RAV or loves the RAV, depending on um, its its condition to the. Oh boy, I can't even talk. I'm trying to read these
So
comments and
if
take
hold
notes.
on, if we go into the fourth dimension, which Joe likes to go into, see if I can get this right.
Mhm.
On one side of it, you're creating a high energy field, and on the other side of it, you're creating the absolute opposite of it in the fourth dimension. So it would be a very low energy field where light cannot escape.
Makes sense.
Well, I don't know if it'd be low energy. It might still be high energy, but the light escapes out of one, doesn't in the other. Right on the opposite side.
Were you seeing that? Because I wasn't looking for that, but you have the keen eye to see that it's not dark, it's
Well, you're
absence of
getting,
light.
yeah, the whole thing is getting a mirrored effect. Okay, in
Okay.
every one of these you do, and I don't mean that as in it's creating the same image on the other side. It's more like an inverted mirror, where
Okay.
so I want to say this. On one side, it seems like there's a lot of light. On the other side, there's probably no light. And then on one side, it's putting in a very high frequency, but then it's returning a very high heat level.
Mm-hmm.
It's almost like, and I wouldn't be surprised to see this, although you guys say it's never in there.
Mm-hmm.
I wouldn't be surprised to see if the clay heat was way hotter than the RAV itself, that it was actually building out in cold plasma instead of hot.
Hmm.
It just for one reason. It has to do with the frequency going in and the frequency of the RAV itself.
Okay.
Because it's like it hit a mirror and changed it. And now I could be completely like 100% off, okay? But there's something weird going on there. It's something that inverts when you do it, and it's going back on itself and
Yeah,
rewrapping in itself that's causing something different.
I see that. What did you think of the ring magnet inside the vacuum chamber? And it was a calf. And since the calf had to stay fully formed, the chaos had to happen on the anode side. What'd you think of that?
Yeah, I think that's so cool, by the way. The I don't want to say it. So you see the calf and it gets brighter, right? And then you bring it down based on what you're putting into it, right?
Right,
But the magnet again keeps it in the center.
right.
But I didn't see the chaos on the outside of it. Okay,
At
I
the
see
anode.
on the anode. I see extra breakout that starts to happen. So
Yes.
it'll get thicker and thinner. Is what I did notice. It fluctuates a bit.
Okay. I um I mean that makes sense, I guess.
I don't think I was seeing the same thing you are.
Yeah, which is great because why be around people who think like you? You know, you wouldn't learn anything. So
That's great because nobody thinks like me. So I must learn a lot.
I always love it because the first word out of your mouth is no, and you do this. Whenever I pose a new theory, you're like, I haven't even finished my theory. You're wrong. I love it. Just test everything. Devil's advocate. I love it.
I
Lion
don't say it
Fire
like
says,
that. Go ahead.
sorry. Lion Fire says, what if a plasmoid was a torus? I'm not really knowledgeable on plasmoids. Nathan, are you?
What if plasmoids are torus? They're talking about
What
toroidal
if a
structure.
plasmoid was a torus? I thought they were.
I don't think that they are.
Oh, okay.
I think they relate them to the toruses, but I don't think that they are. The way that they build them out by putting the center structure in it when you build it out in the chamber for fusion, you create the
Mhm.
torus shape, but I don't think naturally they are.
Yeah, that makes sense. I saw some Taurus, I'll say donut, some donut-ish shapes though, especially with a calf. It would go from sphere to sort of a fat donut. I mean, or did it look just spherical to you?
Well, I only see them. Okay, so the only time I've ever seen the donut shape, okay, and
Mm.
let me rephrase that. I was told what it was when it was by a volcano, okay,
Okay,
and that came from John. He had a picture of it,
okay.
and then there was the one that was in that ball of what was it? I want to say it's hydrogen. It could be something else. It was basically it was
Hydrogen.
that ball with that little ring in there. You know what I mean? You saw the plasma
Yeah,
donut.
yeah, yeah. Yeah,
I saw that one, but those are the only times I've seen it built out in the Taurus. But I've never seen it do that otherwise.
yeah. I've never seen it either. I know I have that exact noble glass ball, where they put the form of the torus in there, but I
Hmm.
don't have the high frequency, very high frequency Tesla coil to put under it, so the torus forms inside of it. That smoke ring, is that what we're talking about? The same thing?
Yeah,
Okay.
I think it more has to do with the magnetic field. How you say this plasma builds out, and then how they build the magnetic field around it. Because that one is even built with the high frequency magnetic field because they just use that wire that's wrapped around the bottom.
Yeah.
But that could also mean that instead of where the RAV has a center point, that means that this thing has a spherical structure that it's going on, so it changes the plasma and how it builds out.
Hmm. Hmm.
Because
I
there's
feel like
nothing natural. There's nothing natural about a chamber that they're putting it in. Just be clear when they do it for power. There's nothing natural about that.
it's super complex circuitry actually to get that to form, and then they think that you're right, it's some sort of natural phenomenon. It's not. And that's why it's funny because you have the same rule I had, but I never voiced it, and you said it. I have a 10 component rule. If I have 11 resistors, diodes, and transistors, I'm not going to build it. I'm almost the same way. I just can't. I feel like the answers are all around us. We just have to look.
Yeah. You're canceling a lot of things out when you start putting more components in.
Exactly. And you know, you and I are not afraid to go out on a limb. I mean, when you're out in your butt huggers in the night lighting light bulbs in the pond that you had dug midnight, and there's just the moonlight and you and those big
Oh,
light bulbs.
yeah, there was some extra moon going on there. Yeah.
There were 2 moons that night. Oh, I love it. I've
Oh,
shared it with people. Look at this guy lights light bulbs in a hole he dug in his backyard. And they're like, what? But it was a cool experiment.
oh yeah.
I loved it.
That was so bad, Sean. Like literally, my pants were falling off the whole time, and I didn't realize it until later on. And I just go, "Man, I'm shining a lot of moon out here." Yeah, it was bad. So I put a big
Oh,
old sign over it, which just made it worse.
it was awesome. It was good times. It reminds me of Gerald's cat whizzing on the router. He
oh,
goes, guys, my router's out.
I love that.
Uh, all
Oh
right.
man.
I got some comments. Let's see. I'm so sorry, Ian. I don't even know how to say your last name. I bet you don't know how to say mine either. So we're fair. Let's see here.
Are you talking
Zerglab,
about Ian? Bog Irish?
Bog Irish. Is
No,
that his last
that's not
name?
his last name. That's
Okay. Okay.
that's like a saying or something for Irishmen.
Oh, interesting.
Yeah, I
It
know his
was,
last name, but it isn't that.
oh, it's called.
Yeah.
Oh, that's oh boy, Norse? Viking? I think these Gauls are ancient French, I think. Ancient Frenchmen. The Gauls? No, that's the Gauls.
No,
Sorry.
no, he's definitely Irishman.
Well, I'm talking almost prehistoric. The people who moved to Ireland and became Irish, I think they were Vikings, of course, and then
I
they're
remember
Irish.
I remember the show we did with him the first time. It was an Irishman from Florida.
That's funny. Yeah, that's you're not on a cold island. You're in a nice peninsula.
Yeah.
Uh,
Nice warm
Gaul with
environment.
a T. Yeah, Gaul with a T. Okay. Because if it
Love it.
was Gaul, that would be French, old French. We could just call Ian Frenchy. No, that'd be
Oh,
horrible.
I don't think you'd like that.
No, he would hate it. He's fun to tease. Actually, he's more teases me though, I think. He definitely
Mm.
kicks my butt when he's asking questions and I don't have answers. Does
Oh,
he always do that?
oh yeah, he gets me a lot. I have to look stuff up. Don't get me wrong.
And then you
No,
find
no.
out you're wrong and he's right, even though he's not pointing your nose in it. He
Oh
doesn't
yeah.
believe it.
No, no. You got to be very specific
Yeah, we got a
because
great team.
he's testing what you're doing
Yep,
is what's going on. He's not
yep,
really saying it right up front, but he's testing the same thing you're doing. He's looking for the same result.
yep. Yeah, I agree. I'm glad you could make it, Stefan or Steven. No problem. I guess you can replay it if you're interested. I did a lot of stuff in the beginning around Ravs and a new creature called the Cathodic Fireball. So yeah, good to see you. Um, Stefan or Steven, where are you at? I think he's in Ireland. Stefan Drysdale?
Yes, I think it. Well, hold on. I know it's not in the United States. That's for sure.
Yeah, maybe Australia. Uh, Eighth Sinner says if you start calling the Irish French, and you're gonna wake up with a Scottish hangover. Yeah, oh
Yeah.
yeah,
Oh
oh
yeah.
yeah.
New
Uh,
Brunswick. That's where
New
he's from.
Brunswick is in England, isn't it? Oh no, New Brunswick is Maine. He's in the States. New Brunswick's Maine, right?
There you
All right,
go.
Steven's gonna have to let us know. Ian says proper Celts don't get hangovers.
They just keep drinking.
Yeah, I worked for an Irish-owned company, and they had a kind of a big dinner, upper management dinner. And I hate to say it, but the stereotype was there. They all were drinking. If you, the only people who were not drinking in that meeting, dinner, were Americans. There was no, an Irish did not have a beer in his hand. So yeah, there was a law on the books in Chicago 100 years ago where it said that Irish could not drink beer on the weekends. Yeah,
Really?
yeah, because they're rough and tumble. They were tough people in Chicago. And then when they got drunk, it was like burn down the city. So yeah, so
Wow.
yeah, they picked them out.
Always wanted to visit one of those places that was like an old Irish pub where you go in and they got some boxing ring in there and then you get drunk and you get in there and start punching it out. It
Yeah,
would have just
yeah.
been fun to visit, hang out, throw a few blows, get some more beers. That'd
My
have been
my favorite
awesome.
That's my favorite area of history and location geography is Ireland, England, Ireland, and Scotland. That's my, and the 1600s. That's my favorite era. It's because a lot happened. A lot happened that shaped our country. Um, and my favorite. It's funny. My favorite guy of history is I can't even remember his name now. Oliver Cromwell.
Mm,
And he was a general in the 1640s who won the English Civil War. And he was the only guy that could conquer Ireland. So today, even to this day in Ireland, if you say Oliver Cromwell, and I maybe an old Irishman, I don't know, but they're supposed to spit on the ground and say, curse, curse, curse Cromwell, curse be Oliver Cromwell. Yeah,
wow.
there's, in fact, they have a anniversary where they open cans of tomato juice and they throw them against the wall to simulate the bloodshed of Oliver Cromwell in Ireland. So there's a lot of intensity about that guy. Now, Ian might just correct me wrong, and I'm all off base, but this is what I read. Um, but yeah, he's my favorite character in history. He's kind of a good guy, but a kind of a villain.
Mm,
But we owe him a lot. We owe him a lot. He gave us our armies, the way we structure our armies. He's
mm.
just a really, really great general.
Okay, I got one for you.
Okay.
Civil War general that burned everything and won us the war.
Oh my goodness. Sherman?
There wasn't this Sherman's March or something like that.
I think it was Sherman. I had to be Sherman, yeah, because you scorched earth. Oh, I think it's Sherman. It's where we got the
And
Sherman tank because he just plowed through, ran over everything. Now they might correct us here in the chat, and please do. But yeah, I think it's Sherman.
yeah,
I
I that's the name that rings a bell in my head too.
yeah.
Yeah, under Ulysses S. Grant.
Let's see here. No, not sure says I make a lot of jokes. Oh, okay. Not to do with our conversation. All right. So the calf and the rab. Next steps. I'm gonna start building electrics again, so I'm gonna probably take my foot off the gas. And if my health bombs out, I guess everything will go slow. Um, but now that it's cooler, I have my new setup for the electrodes. We're gonna, you saw that electrode at the beginning, so I'm on the right track, I think. Because what kind of plastic disc holds a high voltage charge 3 months later? I mean, and you saw it move that rotor, right? At the
Hmm.
beginning. So, what are your thoughts on it? Do you think that's the right path? Do you think
Oh,
that it's going to reach electorate stage, a full-fledged electorate?
I think you're definitely on the right path. If it's still holding charge after this long, what has it been, like 3 months, 4 months?
Yeah, 3 or 4 months.
Yeah, you're definitely on the right path with it.
Awesome. I'm going to take that recipe. I'm gonna crank it up. So crank it up to this, and so I'm hoping if I can crank it up, then I can place them next to that rotor, and they can actually turn the rotor without me moving the electric. So that's the next goal. It's a big goal.
Yeah.
It's just not easy. There's a reason why it's not done. It's not easy. Thank you, Darren. Appreciate it. Awesome. I'm happy you like my experiments. It means a lot.
Yeah.
Will do.
Everybody loves it, man.
I appreciate it. You guys are awesome. Thank you, Jan. Thank you all, guys. You guys are all awesome. So Crypto Builders Keep says, I have some nice electric recipes we'll be working with. We'll share the results. Oh yeah. Oh yeah. Definitely. Reach out to Old Man Builds, Nathan here, and he can take a look at your stuff and see if we can get it on a live stream. Love it.
Oh, absolutely.
Nathan's awesome about his channel. He likes to lift up all of us. He's the not the servant leader, but I think that might be the leader model. That's right. He's made us all leaders. John Gray says, "You look good, Shawn. Please take care." Oh, thank you.
Yeah, the kind of the object of the channel, man. Most of it is everybody does experiment. So come out,
Yeah,
show it, be proud. You know what I mean? We're not here to argue with you. I'm not a gotcha channel. We're here to stand behind you in your work, and hopefully you get some more viewers to your channel if that's what you're here for. But yeah, I mean, we're never here to discourage anyone. That's for sure.
yeah. And if we've discouraged you guys, I apologize. It's I always feel elated when Nathan has me on his channel because I don't have to be constantly going back and that's 5 milligrams and really that's this and that's that and spend an hour being accurate. And my experiments are accurate, but if we all play little games about our words and how words this and that, and we're gonna miss the forest for the trees. And so I feel like Nathan's created that channel where, you know what, just like you're having a conversation with your friends, you want to show them some cool stuff, tell your friend your theories, and then let's test them. You guys all have skills that we don't have, and we can all, I think together we'll do something awesome.
Absolutely. Well, that's the whole point.
Yeah, stacking electrics is definitely on the list, Stefan. It's
Nice.
definitely what I want to do, and because it makes sense. My guess is what you're thinking is that it will boost the field, and if anything, it'll uh, up the longevity of the field, because that's what I'm kind of running into is that electret that I showed at the beginning, and I placed it and it was spinning that rotor real fast. That only lasts maybe a minute. Then I have to put it back in the aluminum foil, and then a few hours later I pull it out and then it runs for a minute. So I think stacking them is going to say, oh, if I stack them, they'll run for an hour. That's my guess. I still haven't tried your trick, Nathan, with the aluminum net material, the aluminum mesh,
Mm-hmm.
because I can't find it where it's not treated. The screen doors is aluminum, but it's coated with something. And that coating, I think, is gonna mess with the results. Like, where can I find bare aluminum mesh? It's always stainless steel for some reason. So yeah, if you guys can point me to a
I have some.
fine-grained, huh?
I have some.
Can you point me? Send me a link.
Yeah,
You buy
I
some?
think I did a while back. I have it at Home Depot.
Oh, I'm sorry. Oh, that's my memory. Could you
No,
resend it?
no. Yeah, I'll resend it. No, it was I picked it up at Lowe's. This one I picked up at Lowe's. Yeah.
Okay. We have a Lowe's. Just gonna write it down here.
I think everybody wants to know in those electrics, Sean, are they like magnets when you stack the magnets? Does the field get a little bit bigger? You know what I mean? Is it a little stronger? Would it turn that wheel already just by stacking a couple?
Yeah. And it's not a high voltage field thing. So that's what I'm learning because that that disc that I showed you, that's running 20,000 volts plus. That's the field on it. 20,000 volts maintained for 3 months. That's pretty incredible on a piece of plastic.
Oh yeah.
But yeah, but um the density of the field depletes. So it has no, it loses its force. And I think when you stack the electrodes, you're increasing the density of the field versus increasing the voltage of the field. Now, I could be wrong because I haven't done it yet. Are you thinking that stacking them will increase the voltage or keep the voltage the same and increase the density of the field?
Well, in magnets, it's multiplying the magnetism. So in electrics, I would imagine it's multiplying the electric field because you're not okay. So if you left it in the aluminum and spun it, would you get a field outside of it?
Hmm.
You see what I'm saying? That's always an interesting question.
Aluminum mesh or aluminum?
Well, it's just aluminum. Say, for instance, okay, say you made a rod that goes up, and then you have a spherical electric, but it's covered in tinfoil, right? So just
Yep.
like you normally would, right? But then you have this another rod coming down, is 3D printed with a cap over top of it, so it locks both ends. So you're sitting with a sphere inside the middle of it, and then you just spun it. Okay,
Mhm.
would it build out a field? You know what I mean? That's what everybody wants to see. They want to see how far that electricity passes out.
Yeah.
You know what I mean? And I'm just trying to give you a structure. Probably would have been better to just let me build one and show you. But
It's great visual though. I
it,
like it.
it's like Merkaba. Remember how he's building a structure for that magnet, that
Yeah.
ball magnet?
Hmm.
It's kind of like the same thing. Is if that structure was aluminum for you, could you put the electric in it and spin it, and would it keep it charged at that same rate as it's spinning it?
I'm writing this down.
So it's just kind of interesting the way that builds out because everybody wants to see. This is what I think anyway.
Hmm.
Everybody wants to see the electric field give up to the magnetic field when it spins. So when I do my Utron coil, in order to get it to that high, I have to pull it at about 7,800 RPM. Okay.
Hmm.
If I could do that, which is simply just a little RC motor, okay,
Yeah.
then it should produce a magnetic field coming out of the center, you know what I mean, as it rotates.
Yep. It would.
So
It's
that's what people just want to see. They want to see how it works, you know what I mean, what the strength is, so that they can judge in their experiment, hey, is that what I need?
yeah. That's good. I know. I check in with Jarvis all the time, and he's the master electric. He's the
Hmm.
ninja, and he's gives me all kinds of inspiration. And so I like these ideas, Nathan. I appreciate it because I do like the Merkaba or Merkaba. I don't know how to say it. Because I think that when you are spinning at a certain speed, that magnetic field does things that you wouldn't expect at high
Hmm.
speeds. And I think that taking that concept to electrodes, that what would it do at high speeds? Yeah, I mean, there is so Brent Jarvis has an idea where you play with the fields because that are not moving. So if you move a magnetic field, it creates an electric field that's perpendicular to it. If you move an electric field, it creates a magnetic field perpendicular to it. But an electret is a electric field, no magnetic field. When it's not moving, it's just a pure electric field. And it's not the electric field that's all around us. That's all equilibrium, it's canceled out. The only time we really know the environment has a strong electric field is when we drag our feet on the carpet and touch the door and get shocked. Okay, now that's a moving electric field, and that's electricity. It does have a magnetic field. But if you were to say, I have a permanent magnet and it's not moving, and if I have a permanent electret, it's not moving, and if you lay those fields together, because they're always usually supposed to be perpendicular, but if you lay them parallel to each other, have we ever done that before? And that's one of the things I'm trying to do, because then one's not creating the other. They're literally being forced together without them being creating one another. And what if I did drop a electron on a magnet and it just floated at an angle away from the magnet because of that phenomenon? The magnet is not creating a field, but the static electric field jumps on the static magnetic field. All of a sudden it creates this new phenomenon. And so that's kind of one of the things that is on my list, and that's total good ideas from Brent Jarvis. He's really good at this. I've just been the grunt pumping out electrets until until baking electrets until they work. And I'll be honest, I don't want to toot my own horn, please forgive me, but electrets aren't easy. Okay, I'm just gonna tell you. That's the hardest thing I ever done. Ravs are hard. Electrets, oh my goodness. Yeah, electrets are, because you're playing with this phantom field, and you're trying to make molecules obey you in a way that they just haven't been done before.
Yeah, I agree with you, Shawn. You're a genius. There's no question about it.
You're kind.
No, you are. You do a lot of things, man, to make it look easy, where the rest of us are just trying to catch up.
Oh, you're nice. Thank you. I appreciate it. I have the same for you, though, to be honest. I mean, when I saw you take my Ravs to the next level, I was like, oh man, I don't even know what Ravs are anymore compared to you, because it blew me away when you had the anode and the cathode as a Rav. And that reminds me, but big kudos to you, because I still want the ingredients for that recipe. Um, uh, when you have the dual Ravs going on, the cathode Rav and the anode Rav, are they silent? Do they squeak? Like
Then
actually
silent.
squeak? Because there's this buzzing squeak sound that I get, and I thought maybe you were getting it. It's not that
No, I
sound.
take it back. They're not silent at all.
They're what?
They're not silent at all.
Your Ravs are?
No. Well,
See,
we got a video of it. You know what I mean? You can hear it.
so that's the thing, because yours look different. Oh, thank you, Jan. You're awesome. Appreciate it. You are spinning both ends like it's magical, but you're also using AC, right? AC or DC? Because you're using the bipolar Tesla coil, right?
I never come out of DC.
Wait a minute. You use the Ultron, right? To create a Rav at both ends.
Yeah, I did. The
Okay.
Utron. No. I did the Utron to create it at one end, just the single.
Mm-hmm.
I used my AC flyback to create it on both.
That is bigger than what I'm doing. I'll just tell you right now.
So
From my perspective, that's bigger than.
Sorry, I could take one ZVS, connect two AC flybacks to it, and make 4 Ravs at once if you want.
Well, I can create 4 Ravs at once. I'll raise your ravs with one.
Create the fifth one. There you go. Love
That's
it.
right. My rav's bigger than yours.
I remember when you created, I'm like, I can't let you one up me on this. I know high
I know.
voltage better than anybody. Come on now.
That's why I was in the vacuum chamber. I got that bigger one from my experiments. That's the biggest one, was that honkin' Rav,
Yeah.
and it's the water. It's just because it's eating up the hydrogen, and the water's destroying my pump, so it's just a mess. But I really, really want a step by step on how you do what you're doing with the multiple RAVs with different sources, the bipolar, Tesla coil, the flyback. I need like kindergarten. This is a coil, because I honestly believe that's the biggest. You've uncovered the biggest from my perspective. Because it's weird. RAVs are not really easy to do unless you know how to do it. If no one showed how to do it, it's not a thing you stumble on.
Right.
And what you did with it, oh my goodness. I'm afraid to say that I did take out one of my Tesla coils, and I thought Nathan needs to give me more details, because yeah, you're doing some voodoo, and and it's not nice that you're not telling everybody.
Well,
No, seriously though, I
no,
would really love if you did it.
I'll tell everybody the secret, and I don't know that it's really understandable until you do it. Sean builds his testicles like an AC flyback. Okay.
There's similarities, yeah.
Oh no. It is the same. So hold on. I built an AC flyback a while back. Okay. Check it out. You know how I did it? I'm going to stack this tall. I divided the lines, so every 1/8 inch opening is what it'd be.
Uh-huh.
1/8 inch filled with plastic, 1/8 inch opening. Okay. All the
Uh-huh.
way down, I created a line right down the center of it, and I wrapped it same amount of turns, and then I crossed down the next one, did the next one, then you know what I mean, so on and so forth, right? So
Mhm.
then I put it in this what is it? Ferrite. So it's a ferrite core. It's
Yeah.
just like this, like a little square ferrite core. You know what I mean?
Yep.
And on
Yep.
the other side, all I did was wrap it with the wire and connect it to my ZVS. Okay.
Yep.
So it's an AC flyback in the fact that both sides are exactly the same.
Nope.
Okay. So
Sorry, Nathan. I agree with most of what you say, but I gotta dig my heels in this one. I call it the deep grooved solid state Tesla coil, because that's how they named Tesla coils, by some, the DRSSTC, the SSTC, the spark gap Tesla coil. I think that's just an SPTC. But you're saying that my deep groove Tesla coil is just a flyback. Well, there's no ferrite. Ferrite is one of the big ingredients that will not work in my Tesla coils. I've tried.
let me see if I
I've
can.
seriously tried. Can't. You can't put a ferrite ring in your Tesla coil and have it. It won't work for as a Tesla coil once you do that. It's just be a flyback transformer at that point.
I got okay. I got $100 says I could do it.
I'll never bet with you. Look,
No, it has nothing to do with that. It's just that the way I built the one on the ferrite
uh-huh.
is exactly the same as the way I built the Utron. The only difference was the geometry. Okay, if I built it into a cylinder, it would have been exactly the same. I think I've showed you the picture of it several times, right? Of the flyback itself, and I don't think you realized what I was doing.
Uh-huh.
The secret was it's
Mhm.
simply a pulsed DC that turns it on. So now whether I put it in the ferrite or whether I put it in a ring around the coil, it really doesn't matter as long as it's, you know what I mean, in there. And that's where I think you and I differ. But if
Yeah.
I gave you both and you turned them on
Yeah.
both the same way and I built the same coil,
Then
I
I'd eat my Tesla coil if you did it. But I would have to see OSCO. I'd have to make a Tesla coil out of like waffles or something.
oh
I
man.
don't believe it. I don't, because the the conventional flyback has the high voltage pulse DC output. Your flybacks have either AC or DC because you have Voodoo flyback. But you're not going to see the plasma I get out of my, like, let's take my Pyramid Tesla coil, the one that's in that big vortex coil one with the 12 gauge wire. You got to show me a flyback that puts out 6-inch diameter plasma.
Okay, so just so we understand each other,
Yep.
when you put them in there, you're changing your cathode in order to change your anode. You took a balanced system and imbalanced it in order to get the purple. And I know that sounds wrong, but it's 100% right because you put twice the mass or 4 times the mass on the cathode side by putting in the dish than the anode side. So it upped the frequency on the anode side by reducing the frequency on the cathode side. But they were normally equal coming out.
Are you talking about coil 1 on the Tesla coil?
On an AC flyback. So watch here. I'll show you a video. Okay.
Okay. Yep. Let's see it. Awesome.
Okay. So right there, you see the coil. You see it stacked.
Yep.
That looks like your Tesla coil,
No,
right? Maybe a little bit different.
Nothing like it. That's not it. Okay. Mine has a ZVS. Yours has a ZVS. Mine has plastic between my rings of wire. Yours has plastic rings of wire. Mine does not have the ferrite because
No, I'm not arguing that point with you. The ferrite, the only reason it's there is to pulse that DC.
But that's the key though, because I don't have the ferrite. I get a massive spherical plasma lightning, the blue lightning, the twirling lightning. You're not going to get twirling lightning out of these two little wires.
Okay, just hear me out, okay? Because
Okay.
you're still not getting it. The primary itself is a pulse DC going in. All you have to have is a pulse DC to that coil, even if I put it in the center, okay, to get that thing to fire like a Tesla coil. Okay.
I mean, you're right, but you're not going to get the plasma, not with the ferrite. And Ian makes a good point. It's going to saturate. And when the ferrite saturates, you're robbing it of energy and you're going to get a stinky Tesla coil.
No.
Stinky.
I'm well aware. Okay. That's not the point I'm arguing here. Okay.
Okay.
If I simply took the little bobbin off of it, I can run it like a Tesla coil all day long. Okay.
When you say the bottom off, sorry, what do you take?
The bobbin. If I just took the little bobbin of wire off, okay, with the plastic, I'll run it just like your Tesla coil and it'll work just fine.
I see. If you put a little coil one.
So what I'm making the point is whether I put that number 1 coil on the conventional Tesla coil wise, or if I put it through the ferrite core, all I'm doing is pulsing DC. Now, the effect is much different in how it comes out. That's the part you're arguing, and you are 100% correct.
Okay, well, I'm just confused.
No, but that's transformer physics. That's the reason why it's doing it. See, but this is the point, and here's what I'm gonna say. Okay, so I'm gonna play the video for you. Okay.
Okay. We need your guys' theories in the comments. By the way, don't let Nathan fool you. He's the Jedi Master of Plasma, okay?
So it's a totally bad frequency and everything, right? I won't even lie to you about it. It's horrifyingly bad. Just like
Okay.
you said. Okay.
Yep.
You're not going to get an argument with me out of that.
Yeah. Yeah.
See, a little tiny, little weenie, yeah, little one.
Wussy Sparks. Wussy Sparks.
Yeah. So, but that's different. So, what's different in that spark than it is in your Tesla coil? I took away the high frequency and I gave it low frequency because I added the ferrite core. I added mass to it in order to lower the frequency into it.
You added capacitance to the coil, so you
Hey.
slowed down the frequency because you
There
added
you go.
capacity. That
So,
ferrite is a capacitor, basically.
so what happens when you did your tray on the bottom? You lowered the frequency in the bottom, okay, to create
Yep.
more of that white fuzz, that higher temperature. And you raise the frequency in the top one because as you see the way it's built, it's equal on both sides. Both sides are
Yeah.
crappy, okay? But
Yeah.
that wasn't the point. It was that they were equal on both sides coming out,
Mhm.
which means by taking this end and adding mass to it, you created heat at the bottom, but this side took the high frequency end of it. So you made it into a DC flyback without even trying because you got high voltage potential here while you got low voltage magnetism here. Okay.
Hmm. Okay.
So that's what happens in these things. And I'm trying to tell you guys that. That's the secret to these things. That's why I keep saying I'm laughing because they're all the same. People get really upset with me because they say, no, it's this particular, just like you do, this particular thing. That's what I'm told,
Yeah.
that's what I'm taught.
Hmm.
But the genius is understanding they're all the same thing. And if you just change it just by a little bit, you have the different thing.
You. It's like you're like when I was a software engineer, developer, architect, everything computers, database engineer. But because I had to build these systems, program these systems, I didn't have I don't have past a ninth grade education. So I had to create my own math. Then when I turned 48, 49 years old, because I'm 55 now, I had to go to school to learn algebra. And when I went into algebra, I actually had a better math than algebra for what I needed to do. But it was just so hard to change. And I'm too old, can't teach an old dog new tricks. I mean, this is a crude analogy, but you sort of created your own science and it just works better than everybody else. But it's your own. It's your own. I can't. So when I step in, I go, oh, how did he do that? I always do that when you make an experiment. Like, oh man, I rack my brain. I'm an intuitive uh fringe wannabe. But you're blessed, man. I don't know how else to say it. I know it feels like we're swimming in a hot fudge sundae right now and holding hands, but it's just true. So that's why sometimes I look at it and I go, I don't get what you're saying. It's you just have your own, you've created this system that works and it's better than what I've seen.
Well,
It's simple, but it's not.
the whole point was, Shawn, was to create two RAVs together. You needed to understand that both sides are equal.
Yeah.
Therefore, both sides can be anodes.
Mhm.
That's how it works. Once you create the cathode to create the opposite side of it, now you realize I have two anodes on my hand because the energy coming out is equal in both. You see, we're not realizing that the cathode, when they create that chamber,
Yeah.
it's changing the frequency on us in order to make that RAV work. You see, it's creating that bottom portion where it's like a swirling magnetic field that's going on in there. And when you get a swirling magnetic field that goes on there, it changes the frequency of the anode coming in to make it go to a very higher frequency while the bottom's at a lower frequency. So what I suggested to Joe, and I suggest you too, you take these little things like this, right? The little bar thing. Okay. They have two screws on each side and just little bars that goes in between, basically to hook two wires up, right?
Yep.
You take that and you take your anode and your cathode and you take these two things and you put them to the side. Okay.
Mm.
Then you take your wires, connect them in there, then go connect them to your anode and cathode where they normally go in your RAV. If you take your oscilloscope and put it next to these two things, they'll tell you one frequency.
Right.
Then next to your RAV, you're going to get a different frequency altogether. And I guarantee you it's a fact. Because what I see coming out of it going into your RAV, remember how we saw the light purple? Then in the RAV itself, and I should just pull the picture, it turns yellow. So I know the frequency hit different. And this is
And
something
it showed up in my test that you're right, that it is different frequencies. And you called it when I went in the vacuum chamber, it cut the frequency in half. You already knew that before I told you.
I knew it as soon as I saw it.
So here's what I've learned. Yes, Papa, this is my hair color. Yes. Thank you. I do know nothing to my hair. It's a blessing. Both sides of the family. We have hair like Absalom. You can pick us up by our hair. All right.
So this right here,
Yeah.
okay, off of your anode, which has back pressure on it, you can see it right there in the first little roundness that comes out of it.
Isn't that cool? You only see that in the vacuum because it's exaggerated. It happens with the wrap, but this is exaggerated so you could see it.
And then the purple, okay, it is, you could see the purple coming off it. So you know that's high frequency. Okay. But then when it hits the cathode side, it's all yellow. So we know it lowered the frequency and upped the amperage, which means you have a higher magnetic field going on inside of the RAV right there than you did going in with your anode.
That makes sense. The anode is cool, Dennis. The anode is never hot. Only the cathode. Good question though. So I've learned something about you, Nathan, that it helps me understand because you see the universe as it is, and everything's an effect. A lot of people focus on cause, effect, but you'll take all the effects and construct it. And that's why I think you get your unique ninja skills. So you'll say, everybody goes, this causes heat. And you say, no. This is heat here. And then there's this here. And you'll build the whole thing model perfectly, but it's all effects. I'm trying to find the cause. And I don't know if it's like a dyslexia you have or it's just you're very geometry oriented. When I did take geometry before algebra and I was in my late 40s, geometry was natural. I could write geometry proofs. I got really good grades. It was the algebra that just took me to school and spanked me. I mean, I was terrible at algebra. I'm still terrible at algebra. And I wanted to get to calculus. I don't even know algebra to get to calculus. But yeah, I like how you think because I always get some good takeaway from you. Always. I always go, hey, how did he know this little bulge thing here on the anode? So, and Joe has that gift too. I think you guys are iron sharpens iron. Yeah, I like eighth sinner says you're half alien.
I love it.
It's true. I mean, somewhere there's an alien on another planet that looks like ZZ Top. That's Nathan's twin.
You know what it is, Shawn, is you guys all read the book, right? Like you go in and you learn all this electrical theory and then they tell you exactly how it works, right?
Right.
Well, when you don't learn electrical theory first and you go in and do just a bunch of electronics and stuff, you just see things of how they actually are working. So you do cause and effect a lot and you go, okay, I know that they could say this, but it's not what it's showing me. It doesn't show me that. So I cannot put something in there that it says I put it in there when I don't see it. Okay. And you better have pretty good cause to add it in there if you don't see it. So I fight with people about it if it's not there. You know what I mean? If we can't prove it's there, I don't want it in there because it would be
Yeah.
wrong to lie to you and say, I think that's in there based on this, but that's not what I think. I see this, so I'm
Mhm.
telling you it's there in this. So, you know what I mean? And that's a different
Yeah, no,
perspective I come from.
it's great. You're also not really cornered. When you learn, let's say you take a class in electrical engineering, you're narrow now in understanding electronics. Now you can build circuits like what we're working on now or talking on right now. Excuse me, the computer, the LCD monitor, but you can't think in ways that everything is around us is potential. Everything around us has opportunity, and everything around us is ready to take to give energy, and we don't think that way to figure out how it does. I think that's why that's a second reason why I love being in your community. To be a fringy, I don't know. Are we OMB, OMBs? Are we OMBs? Hey, that's a good idea. Instead of you're my homies, we're
Oh my God.
OMBs.
That sounds
And
like
you
an
can,
old group. You know what I mean? Like we're
you,
singing the oldies or something.
well, you got the gray in your beard. I mean, you just, hey, Shiny boy,
Oh,
how's my
I
OMBs
don't sing
going?
in a choir, that's for sure.
Oh boy,
Oh, oh, that's funny. Oh,
I'm having a
no, but
good.
it's all part of a great community here, man. That's the way it works. But by the way, I just want to give a shout out because I know you watch it, Sean, but the Traveling Fools channel, by the way,
I
totally
saw it.
awesome people.
I subscribed. Oh yeah, their channel's awesome. You led me to them.
Yeah.
That's where
They-
the stainless steel cigar fell from the sky.
yes, yes, they had other names for it, but I try to be respectful now. A lot of people yelled at me for that one.
Oh, sorry guys. Um, I shouldn't make light of something so important. So
No, it's
forgive me.
okay. You know what? We are who we are, man. I don't ever plan on changing. So just take the good with the bad, I guess. You know what I mean?
We're all old crusties. I mean, come on. What do you? I mean,
I loved your first name for it, by the way. That was the best one.
the
So
Ravs.
no, for the cigar thing, it was hilarious.
Oh, do you want me to say it? No.
No, probably wouldn't be good or appropriate, but just do what you want, man. He said,
Ulysses, Ulysses says grandma's rolling pin pie maker. Oh, he opened the door. I thought it was oh, but what did I say? A stainless steel tampon. That's what I think I said. That's so mean.
Sean, where's the string?
Oh, I
Where's the
know.
string?
It's so horrible. I'm so sorry, whoever I'm insulting.
Oh man, you gotta laugh sometimes. No, look, the guy. Be honest with you, man, came up with some kind of rash or something. So I hope he's okay. And it
Yeah.
looks like he got some kind of irradiated material, and I don't
Oh
know what it was
no.
from. Yeah, but that's what it looked like. To be very honest with you, I know we made
Yeah.
a few jokes about it and stuff like that, and I wasn't
Oh.
trying to joke at him. It was just that
Oh.
it looks like what it looks like. You know what I mean? So it
And
is what it is. But
we
I hope the
nickname
guy's all right.
things all the time. It's kind of an affectionate term when you give a nickname.
Oh yeah,
And if the nickname makes us laugh, it's a benefit, right?
we'll never forget it.
If it had some name like the comma luba dubatron,
Oh my
we'd be like,
god,
what? No, it's the flying cigar. Oh, I know what that is.
got it, the Kamala Lubatron. Oh, that's the best, Sean.
It's horrible. Oh, so
Oh man,
Crypto
this
says,
is
what's
so
our
fun.
opinion? Crypto asks, is it alien or is it man-made? What is our opinion? I'll start with you, Nathan. I'll give my thoughts.
I'm sorry, say that one more time. You asked what?
Yeah, Crypto asks, what's your opinion? Is the stainless steel 31-inch object, do you think it's alien or do you think it's man-made?
Okay, there's two ways I would say it. Um, One, I think it's man-made. Okay,
Okay.
I do not think it was an alien thing. However, I think there are some strange things going on with it. Okay,
Yeah.
he's getting frequencies off of it, and it's messing with the lighting. What my two thoughts is either one, he got near an area where he wasn't supposed to be in a missile site in the desert. Okay,
Yeah. Mm-hmm.
and that's one. The second thing, and
Um,
the absolutely crazy thing could be
mhm.
when you things go missing and they phase shift.
Yeah.
Where do they end up? Because you always look at it when okay, Otis T. Carr would say his flying device would phase shift and then it would be gone out of phase forever,
Okay.
right? You wouldn't know where it went. What happens if these things are just reappearing and somebody made this? You know what I mean? It sounds like the craziest thing in the world, right? But it makes the
Yeah.
most sense out of anything because it's like, oh, it disappeared where? In the time somewhere, and then where did it come out? Somewhere else in time. It's like this guy has a business suit on and he showed up in the past. Why? Because he would have phased out of time. You know what I mean? It just seems like the weirdest thing in the world, but it could be the craziest thing is what it is. It's like, how do
So
I get a 50 million-year-old hammer, 50,000-year-old hammer? You know what I mean? Back in the day, and that's what
yeah.
archaeologists put up. Where it looks like a modern hammer. Well,
Yeah.
if it went out of phase for some electrical reason and then it popped up back in that time, well, then that would be why it's there. Just an oddity to the thought.
It's funny because you picked option three. You didn't say it was man-made, like the guy machine shopped a giant, metal Oscar Mayer hot dog. You didn't pick it came from aliens. You sort of said, no, it's ancient technology created by men that phase in, phase out. That's a really interesting theory. That'd be tough to refute. I mean, when you look at certain technologies in the past, they were advanced in some ways. There's a book I read where this historian, she literally takes you to the dawn of man, but only by evidence. If this rock is stacked on this rock, well, then we're going to call that mankind progressing. So as she goes through, and this is literally right after the Babylonians or some real ancient society, but there was an area where they found, I want to say 70 cities or towns, and each house had running water. And I thought about that for a second. They unearthed this in archaeology, and it's in this book. It's a great book. Um, but I had to look it up. In America, we didn't have in-house plumbing until every home in-house plumbing until like the 1960s. How did they have all the houses plumbing and we didn't get all our houses indoor plumbing until the 1960s?
Is
Now,
it that
granted,
late?
yeah, there's parts in the South that were, I mean, in the 1950s, it was in the South, the outhouses were still used. Oh, yeah. Or basins instead of running water. You can look
Hmm.
it up. Um,
I remember my
but
dad telling me stories about moving the outhouse back, and you know
yeah.
what I mean. So people would fall in the little hole with all the poo. And it's the middle of the night. It's out in the middle of nowhere. They don't realize.
Oh, oh, why do we always end up in bathroom humor? It's always,
My
I,
fault.
we're all inside of us, we're all junior hires. I mean,
I just love to laugh, man. So if I can get a
yeah,
couple of good laughs, I'm good for the day, man. So
I agree. I agree. When you smile, there's scientific proof that it releases endorphins. So just smiling helps us health wise. Yeah, I appreciate it.
Oh,
So
yeah.
this is the longest I've gone. Whew.
Yeah,
Hmm.
Joe says he got that thing levitating. He said that on the Discord he'd show it. He says he's having trouble with the camera, though. It's picking it up when he needs. He was having trouble fumbling with that camera earlier.
Yeah, you know, I didn't mention this in the presentation, but there are field effects in these experiments that we're not really understanding. When those rafts are getting big in that one video,
Hmm.
all the hair was standing up on my arms when I leaned on the workbench. As soon as I took just the work, it's wood with a rubber mat, everything is all safe, and the hair just my hair was sticking up on my arms, and I thought, okay, what are my safety? What am I not doing safe? Because I've seen this movie, all the hair stands up, and now something bad happens, and it's people think they know grounds, but understanding grounding is a whole science and art. The way grounding works, and there are fields that are not taken into account for, and we saw that. So, guys in the chat, um, Joe had a little thin piece of plywood, the crafter's plywood, the real 16th of an inch, 2x2, and he had some quartz, and he held it diagonally between his fingers, and parallel to the surface of the quartz, the plywould either be pulled down or pulled up, and it was almost oscillating. This is the interesting part. As Joe was moving the plywood over the flat crystal rock, there were other little quartz crystals, and they would just jump off. They would get so energized by the mechanical movement that they would just be repelled by the other fields. I don't know. And there was a repulsion effect. And Joe just showed us this right before our live stream, and that's proof positive of how there's so much opportunity around us. We just have to stop. There's a thing in academia, and I don't want to pick on academia, but this is something to pick on. They're always saying stuff like that's already done before. Nothing new here. And as soon as you have that attitude, you're not going to go anywhere. You're just not. You're just going to kind of follow the stream of fish. And the only way you're going to really make it is you got to swim upstream, because that's where the nuggets of gold are. And I don't want to pick on them again because they're smart people. They're good meaning. Um, they're just fishing out of a small pond. We're fishing in a big pond. I think that they're just in this little. They're all surrounded around this little tiny pond. This little mud puddle, and we're going looking at the ocean. We're out there in the boat, and we're casting out our lines. I really believe that. I really do. And I don't, grow my hair long, hippie, you know, sit in my teepee, which is nothing wrong with any of that. But that's just common sense. It's logic. What do you think?
Oh, dude, if you were sitting out in your teepee, I'd join you, man. Well,
With the salt bricks, we'd make out of
yeah,
salt
yeah,
bricks.
yeah. We'll pull out the good stuff, man. We'll go on a spiritual journey, that's for sure.
Yeah, if you let me bring my
Oh,
Bible, I'd
yeah.
be there with my
Well, you're
Bible.
gonna need your Bible the next day. Let's just say it that way. We'll end up in our, you know what I mean? Your chonies out there doing rain dances. That,
We're putting
get
our
the,
light bulbs in the pond
yeah.
and our chonies. It'd be a triple moon night.
Oh, that's hilarious.
Uh, Crypto
Oh,
Builder Keep says hombres. Oh, boom. That is awesome. OMBRES, hombres. Nathan, you have to say it. Welcome, hombres.
welcome, hombres.
This
I
is
say it wrong.
OMB. What's
Yeah,
that?
I said I say it wrong.
How do you say it?
Well, I said hombres, like a total white boy. So
Oh, hombre.
you got to get some of that Spanish in you. You know what I mean? Hombres with the
Oh,
hombres.
that's perfect. It sounds like a Greek.
That's so bad.
You know,
Oh,
my dad's Mexican and my mom's German, so my eyes are light, I'm taller, paler. but my dad's a short 5'5" Mexican. And so I'm a stealth Mexican. That's where I get my last name, Calderon. It's Calderon.
He's a stealth
I'm a
Mexican.
stealth. So I'll hear people rip on Mexicans. And they'll just be like, those dirty Mexicans, all those Mexicans. And then this one guy did it, right? He's a realtor. He's showing us houses and he says, oh, you don't want to go live in that neighborhood. It's a bunch of dirty Mexicans. Oh,
Oh
you
my
don't.
God, dude.
He kept saying that, right? And then at the end of the tour for houses, he says, fill out this card and we'll get back with you. And I filled out the card and he goes, Calderon, Calderon. He goes, is that Italian? I go, no, it's Mexican. And this guy is with his biggest saucers. You know what he said? I guess I lost this sale.
That's right, you did. Dude, 2 of my kids are Mexican, man.
Yeah,
Total different worlds, man.
yeah, it's funny because I can make fun of my German side and Mexican side, but I love them both. I mean, I'm German-Mexican. The sad thing about me is I don't speak Spanish because my dad was he was too cool. It wasn't cool to speak Spanish when my dad was when in the 1970s when I was a kid. He's a surfer. He was a cool guy, skateboarder, pro,
Nice.
back early 70s pro. So yeah, so I miss out on that. I don't speak Spanish. It's a bummer. I know how to make the food though.
Oh, there you go.
And my
Dude,
wife's Vietnamese, huh?
Family gatherings are awesome, bro. Like you get the Mexican food, dude. They're so good at everything. I just sitting there and try to learn something, man.
Oh, the food. Oh my goodness, yeah. Oh my goodness. My wife's Vietnamese, and it's where French and Chinese collide.
Okay.
And so the French colonized Vietnam. The French gave them their writing, gave them everything. So their food is a mix between French and Chinese. It's like the best food ever. I mean, her dishes.
Oh yeah.
Oh, it's amazing. Thank you on our, yeah, I'm surfing the ether. I grew up on a skateboard and surfing. Yeah, I'm from Southern California. I'm from Huntington Beach. You know where that's at, Nathan?
Where at on the beach? Huntington?
I'm born.
Nice.
I lived there till I was 12.
Wow.
Yeah, skateboard surf. Yeah, interesting. In my grandma's house on Huntington Beach, it was a mile away from the beach. You could see the beach from her house. You ain't doing that today with Huntington Beach. Oh my goodness. So
no, I just came from what was the other one? Oh, I forgot the name.
Newport?
No, it was God, why am I drawing a blank on this? You know they filmed Gone in 60 Seconds?
Oh. Oh yeah, I know what you're talking about.
Yeah, I just can't think of the name of it. Anyway, my wife's grandparents lived there.
Oh, yeah.
Yeah.
We farm tomatoes. That's what my grandparents did in Huntington Beach. They farmed tomatoes. All that prime beach property, tomatoes. And it was by the time I came back I was in my 20s, it was all developed. All developed, expensive. I think Huntington Beach is one of the most expensive places in the world, honestly.
Yeah,
I think
we were in Long Beach. Long Beach, that's where it was.
Bad spots though, Long Beach.
Yeah, that's where we were.
You got the hood out there, don't you?
They literally have houses on top of houses over there, dude. They call them individual houses, almost like a big condominium because they're so close. It's crazy.
It's crazy. It's like Chicago suburbs. We live on the way suburbs from Chicago. It's an hour drive to Chicago down from us right now. drive south straight down Chicago. If I drive straight up, I'm 35 minutes from Milwaukee. So I like Milwaukee because it's a little wannabe Chicago, and you're
Hmm.
in and out. Chicago, oh, you have to drive 5 miles an hour for, oh my goodness, to get in and get out. Yeah, you're lucky in California because the roads are much wider and bigger
Oh
than
yeah.
Chicago. Chicago's horse and buggy roads. And yeah, and 'cause Chicago was big when California was not big. I mean, so it has all those narrow, unplanned houses and stuff.
Kind of like downtown LA.
Yep, exactly. Yep. Yep. And I remember when I was a kid in Southern California, they had smog alerts. So you couldn't go outside or go to school. Up here we have snow days.
Hmm.
Snow's too thick, it's unsafe to drive. In those days, you couldn't go outside and take a full breath. I mean, the birds were coughing.
Hmm.
And
Yeah, it was bad.
I remember that 1970s. And now with the catalytic converters and all our technology, there's no smog almost. Now there's still smog from industry, but nothing compared when we were younger.
No,
Um,
they drive Teslas now.
yeah, that and
You go around rural America, there's not a lot of charging stations. You get where I am in California, all
yeah,
Southern California, we got charging stations everywhere. Okay.
mm, yeah,
It is literally like 1 out of 3 vehicles is a Tesla.
oh wow,
It's bad. Yeah. I just wonder
wow.
what they're going to do with them after the first battery dies because, that's what, $13,000. That's the price of a whole vehicle. You know what I mean?
And there's a lot of nasty chemicals in batteries, and they really don't know how to dispose of them right without destroying the environment. So they kind of like rob Peter to pay Paul. I don't really think I think they're cool. I think people should have what they want. But it's not what they think it is if they think it's saving Mother Earth. Those batteries are poison. I mean, and you're right. We can go in and get a carburetor or something replaced. They got those batteries, right?
Hmm. Well, I think honestly, Bernie might have the answer to that in the way that he breaks everything down with electrolysis going on.
Oh, he's good at that.
Yeah, you break it down to its original elements and then rebuild it. You may have a better process than the way they do now. Eliminate some of the waste.
Yeah, China just started selling their first saltwater battery or salt battery. And I think the output is the chemicals it breaks down to is water. It's a pretty incredible um accomplishment, but they're extremely weak right now.
Mm.
But they're on the market. So, and they're being put in things. So, hopefully they can scale it up. But right now it's rare earths and poison make up those batteries. And they're heavy,
Yeah. Oh, yeah. Make up a good portion of the way to the car. That's for sure.
right? Right. This is
Huh.
too much fun, Nathan. And it looks like the guys in the chat are having fun.
Oh, yeah. Oh, yeah. Well, just talking normal, you know what I mean? Just, you know what I mean? We don't usually get to see you like this. Usually you're presenting. So I think it's nice to sit down
Appreciate
and just
that.
have a chat.
I get to find out how nerdy I really am.
Oh, man.
Cool, cool nerd. We're cool nerds, right?
Yes, that's right. That's the way it is. I don't think anybody's a nerd, man. Just they're into different stuff. That's
I
it.
agree. I agree.
Like all the stuff that they said was nerdy as a kid, I loved. You know what I mean?
And
The
all
the
the
only thing
nerds.
I didn't like was the reading books part. But that's, you know what I mean? Because I always fall asleep. It's like I have like narcolepsy or something. As soon as the book comes open, I'm like,
TT
oh,
Fly.
it's like a. If I ever want to go to sleep, I just open the book, and 2 minutes in, man, I'm done. And I don't know why. I just can't do it.
I mean, we're all we all have our gifts. I mean, we can't force. I mean, you have to have some basic skills, but you can't. You have to play to your strengths. There's a book called Strength Finder, and It was a fad when it came out, but it was actually true. And what it did is you had to answer a survey on the internet. Then it gave you your score. And the idea was stop this thinking about always being focused on bringing up your weak spots. Focus on your strengths and build them up. And then find people who can take care of your weak spots, or get your weak spots to just a stable state, but don't try to perfect them. Don't feel bad that you haven't perfected them. And that came out, and it makes sense because I used to just say, oh, I got to work on this, I got to work on that. And when I read that book, took the test, I thought, no, I'm just going to focus on what I'm good at, and it worked. It worked really well. And my weak points, it's funny because when I was in the corporate world, my weak points was administration, filing and putting things away, and organization. I'm terrible at organization. So I would just find a friend and say, hey, look, I can write you a report real easy, or write you a little computer program to automate your life away. Can you do all my administration? Can you do all my paperwork?
Nice.
Bartering. I think bartering kind of goes on with us. We kind of barter ideas, and hey, give me that, I'll give you this. Oh, you have that, I'll do this. I think that's honestly the best way.
Yeah. Well, because you can't do everything by yourself. That's for sure.
Yep. Yeah, you can't be good at everything.
Dude, it'd be fun one day all of us be sitting in the lab together. You know what I mean? Because
Be awesome.
it would be one of those things that's like, okay, I have an idea, and then you just set it up real quick, and then you know what I mean, boom, it's done. I think it'd be one of those situations, yeah.
It's so, I mean, it's so cool because you've kind of made that for us here. We're kind of all sitting around the barbecue right now with you, Nathan. It's the closest we can get because we're all not millionaires and live down the street. I mean, and it's just awesome. I learned stuff from the chat. I learned stuff from you. I learned stuff from the conversations you have with Joe. It's just, yeah, it's like, I mean, we call each other brothers. Hey, bro. I think there's a lot to be said about that. We're kindred spirits. And
Yeah.
I like that. I like, it's nice coming out from my tragedies in my past. I needed something like this. When you have a big tragedy, everybody changes. Your family members aren't the same, your friends aren't the same, and you have to create this new reality. And I couldn't do it until we connected. I just couldn't do it. And I was locked in this room. I was writing a book, and I hadn't touched a soldering iron in 30 years. And my wife said, stop writing the book, blank check, buy everything you need, get your lab together, build circuits, because I don't want to see you doing this again because it's pitiful. When your wife tells you grab the credit card and run, you don't look back. You don't look back, right? Thank you, John. Appreciate it, Jan. Thank you, Papa. Yeah, you're right, Papa. Aliens are real. Are you an alien, Society of High Sciences? But I appreciate that, Nathan, that this was good for me. And I bet you people here in the chat have similar stories. I really do. I really believe that they're in some place in their life where their social structure is not the way they want it. And then we come into your channel, we have a social structure, like-minded people. I told you about, I'll go to a cool channel. The algorithm will take me to some YouTube channel. I'll watch the video and I'll go to the comment section and I'll write a comment. And then a few comments below is your comment. And your comment is the same as my comment. I've had that happen 3 times. And I thought, is he like stalking me? I mean, how does he know? He doesn't know where I'm going. That's how like-minded we are. Isn't that interesting?
Dude, that's just so funny.
I don't exaggerate. I'm serious. It's so incredible.
We're watching all the same stuff.
And coming out with a different thing, different parts to help get the full picture, though. That's what's cool.
Yeah, Sean helped me when my testicle was on fire constantly. I
That's
would be
how we
like,
met.
it's on fire again, and I'm just walking over slowly to it.
And I gave you the backward diode
Oh,
and
still
the
joins me for a
switch
trip. Yeah.
and the switch on the ZVS, and it worked. It was it worked well.
Sean's running things in reverse and they seem to work better.
That's the photodiodes. Yep. You have to run them backwards. That
I
so
think it's so funny because it's so like opposite of, hey, this is normal electronics.
yeah.
Everything we have is like something backwards in it, and then it works better.
Uh-huh. Yep. Or like your PNP, everybody has NPN, and PNP has this like set of parameters that you don't get in NPN. People are missing. It's awesome. I still remember. Yeah, it's smoking. I shouldn't have voltages high. And you turn it up, and more smoke comes out. You're it's like I'm not getting the output from my Tesla coil. It's smoking. I'm gonna turn it up.
Oh, that's what they tell me. I'm always frying it to find out.
Yeah. I'll tell you what, I'm inspired because there are times I don't want to put everything exactly right because I'm just lazy. So I just flip the switch and just let it rip. I mean,
Yeah.
yeah, just let it go. I was sharing with you guys maybe a couple months ago that I'm working on an indestructible circuit series. It sounds kind of
Mhm.
silly. But I'm building like a ZVS where it never dies and you can beat the heck out of it. And it's like plug and play. Um, I owe you, I owe Ian you I called it Uber. Remember my Uber
Mhm.
circuit?
Oh
Uber
yeah,
one
yeah.
two. Um, Charlie C has my Uber 2. Then I switched to Zed. I built a couple Zeds. I was gonna send you, but I ended up with now um a better best of both worlds, a Zed and an Uber to combine.
Nice.
And no, I'm not calling it Zuber, but I'm gonna be putting those out. I'm gonna get more plasma stuff going. I miss my Tesla coils. Um, and yeah, so I'm excited. Oh, Darren, you want a circuit diagram? So let me write this down because this when I say the ZVS circuit's indestructible, what I'm saying is that the parts that fail, I make them not fail, and the parts that can fail, you can just pull them out, no soldering. It's pull in, pull out. So if you have your resistors won't go anywhere. Um, the wiring between them, circuit boards, their circuits can fry in the traces, and you won't find the fault. You'll pull out every component off the circuit board. They all work. It's a circuit board that's wrong. ZVS are notorious for that. They just burn out the circuit board and you can't find it. You got to trash it. Take off what you can take off of it and trash it. So the Uber or the Zed put 1/8-inch copper pipe between the components. That way now you can run 100 amps and you won't burn out your ZVS. The second thing I do is I solder those copper pipes to the stuff that won't break. So those little toroid coils
Mhm.
on the ZVS, they'll never die. I mean, the wire's too thick. You just won't hurt them ever. So I solder those into the copper pipe. But the transistors and the diodes, they can break all the time. So they slip in and out like plug and play,
Mhm.
like pulling out a circuit chip and put another chip in, swap it out like a SD card, and your ZVS always works. And then you can always just focus now on your coils and your plasma experiments because your ZVS is always going to come through. And now Nathan, you've come up with a way of getting the CVS from Amazon to work perfectly,
Oh yeah.
but I don't have that much brain power, so I just run 1/8 inch quarter copper pipe. Just and so but I'll be sharing that coming up.
You know what
And
would be
so
cool, Sean?
mhm,
Think about it this way: if you put your diodes on a card that looks like an SD card, and then it plugs directly into a slot on there. You know
uh-huh,
what I mean? And then you could literally plug and play those little units that go in there just like that on a little slot device. And
yeah,
then you did your like MOSFETs or transistors the same way, or they just have a little slot. Instead of
yeah.
screwing them down every time, it'd be like a boom. You put it in the slot, it
Mm.
fries, you pull it out of the slot, throw it away, throw another one in there. That would be really cool because that would be like ultimate plug and play fast wise,
Yeah,
but with the correct little parts on them. You know what I mean? Where it's like, oh, I could buy
yeah,
like 50 of these for real cheap, and then boom,
yeah,
you put them in there, and the tracers, as long as you have big tracers in there, like you said,
yeah.
then
Mhm.
dude, it'd be like the best of every world possible.
The I did build one like that. That's the Z. The Z literally is pipes and components, and it's a puzzle. So if you want your transistor out, you just open up the puzzle, pull the transistor out, and the puzzle comes back. But the issue with that is there's such a high frequency signal on the transistors connections that you're going to create a lot of noise on your transistors if you don't have that screwed down connection. That's an issue because if you think about it, when the MOSFET is creating that frequency, it's a vibration. And if it's not screwed in, it's going to then vibrate at a super high frequency. You won't see it move, but it'll vibrate where it'll create all kinds of noise, and it won't. Your circuit will work, but it's going to be uh, the reason why for a zero voltage. Oh boy, ZVS zero. I'll remember it. Is that it's super efficient. It doesn't overheat when you're pushing out amps.
Like
It's
zero
an
voltage
oscillator
switching,
amplifier, huh?
zero voltage switching.
Zero voltage. Thank you. It amplifies the frequency. It takes 20 volts input and then it amplifies it to 7,800 volts at its resonant frequency. And then what we do is we pick off that 7,800 volts frequency in coil one, and it excites coil two, and coil two then takes those amps and converts it into voltage to pump out the the plasma. So I've tried it, but you can't plug and play the transistors unless you want a really noisy, hot ZBS. Does that make sense?
Mm-hmm.
It's a bummer. You're right, though. It'd be nice to just not screw and unscrew. I'll share the circuit and its diagram next week, guys. Uh, Nathan just said, sorry, Joe says, show what I sent you. Did you see that?
Well, I could show it. I don't know that it makes any sense. Let's give a shout out to Timtron out there. He's building a
Hey,
Tesla coil device, man. So I'm waiting for him to get it done. It looked awesome though.
awesome is his coil. What's that name? There's a name for his coil that he
The
has right
Meg.
there.
Well, he builds the Meg. That's what's on his picture right
Meg.
there.
It's the Meg. Oh, that's okay. Awesome. I remember him now.
Yeah, but
He's
he's building Tesla coils on another device. I haven't seen him finish it yet. He got a lot of stuff, man. He's gonna put in there. Really
I
cool
can't
stuff.
wait. I can't wait. He's gonna share on your channel.
Yeah. Oh, yeah. Well, when he has it
Awesome.
ready, or anytime he wants to come on, he's always welcome. Tim's awesome, man.
That's awesome. Cool.
So
All
okay,
right, Bill.
let's see real quick what Joe has. I don't know exactly what we're looking at.
Is it is it a kitchen strainer? I can't see it.
I can
It
see the wire in it, and then he's wrapping a wire around it.
and it's got the duct tape. It's interesting because it has different thicknesses and different windings, and they're perpendicular. So it's maybe because of the different thicknesses of the wires as well, that you're getting a lot of, I guess, perpendicular or parallel waves or fields, sorry. And maybe it amplifies something, maybe amplifies the magnetic field.
I have no idea.
I'm guessing.
I'm kind of perplexed, to be honest with you. Give me a second. Let me.
Yeah, Tim Tron, you're gonna have to share it when you get it done.
Yeah, absolutely.
Dennis has a grill lighter for energy. Yeah, Pizio. Oh, you're saying this might be a grill lighter. Oh, there's a close up. Okay.
It looks like you're gonna pull some voodoo on me. Is what it looks like.
You see chicken bones? I see one. I'm just kidding. Voodoo.
I don't know what it is, Joe. Oh
Joe
man.
has this mind where it's very holistic. It's coming from a 360-degree view.
Yeah, there's something always something going on with something he does. I have no
Yeah,
idea what it is.
that really thin wire that's kind of bunched up on the right, top right. Cool, Tim. Is wait, it says here. Nathan, I want to see what Shawn says about that photo. Oh.
It says chicken bones.
Okay, I see. So it seems like Nathan has constructed a device that will harness or at least treat the RAV more in a 360-degree way to, I guess, maximize the RAV effects. And so I think this is more of a
I think he's putting us on Shawn with witchcraft. That's what I think he's doing.
well, he sent me a diagram similar to that. And then there was a video after that where he was dancing in a big headdress of feathers. So I just thought, yeah, Joe.
Oh my God. Dude, we were making, Mike was doing that. He had his little triangle thing, right? And it's simply copper pipe in a big pyramid, right? And then you had it spin it on the bottom. He said that the rain would come in and you get clouds and everything, right? So I sent him a picture of an Indian doing a rain dance with his face like this, going, yeah! You know what I mean? With a little triangle thing in front of him. Dude, I thought it was hilarious. So we were having a little fun. He said it's the levitating thing he was talking about. I'd love to see that levitate.
Oh, wait. So remember the plywood and the crystal and how it was kind of having some levitation effects on one side and it was pulling down on the other side of that little plywood piece? He's associating it with this.
Yeah, dude, I'm not seeing it.
Grav flux because it's getting stuck. Is he trolling us?
I'm telling you, he's trolling us, Shawn. He's got to be. He's got a witch doctor thing going on here.
Wait, okay, so Joe is serious. He said it scared me. It's off for the night. Maybe he's checking out.
I don't know. I think we're better to let Joe explain it later.
Yeah.
Tomorrow, Friday, he can explain it.
Yeah, we'll look forward to that. Mr. Button, or is it Button or Button?
It's Bunton.
Bunt? I'm so sorry.
It's all right.
What am I saying? Button? Button? Do you get called Button, like button on a shirt?
Yeah, all the time. Or they say, oh man, they spelled your last name wrong. It's Butts. It's butt. What does he race the rest? Your old man butt. Yeah, I get that one a lot.
I
Dude.
I imagine high schoolers had fun with your last name. They didn't know what to do with my last name, so I lucked out. They didn't even know how to say it right. So, Nathan, I am so happy I've lasted this long and I've had a lot of fun, and I appreciate letting me sharing. I really do. This is the first time we've done this where we just kind of hung out for an hour. It's awesome.
Oh, dude, it's totally cool. I'd say your presentation was awesome too, Shawn.
Thank you so much. I appreciate it. I'm off to head out, sir. So, guys, much love to you all. And thank you, Darren, for that contribution. Everything helps. And yeah, Darren, you're amazing. So appreciate it. Everything helps because the quality of stuff you're seeing on Nathan's channel is because of the support you guys give. So lots of love to you, brother.
Right on. I'm gonna close the show out real quick, Shawn.
Okay.
Guys, I just want to say thank you, Darren. You're awesome, brother. Appreciate that. Tim Tron, when you're done, man, and you're ready to come on, the floor is yours. Okay. And that's pretty much what's going on, guys. I just want to say thank you and have a great night. Thank you, Shawn, for presenting today.
Yeah.
You did awesome, man.
Thank you so much.
Really love the
Appreciate it.
conversation as well.
Thank you, sir. Loved it.
All right, guys.
Take
Have a
care.
great night.
All right. Take care.
The old man Bill. The old man Bill. The old man Bill. The old man builds. The old man builds is broken in the head. People not seeing reality has put him in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, and battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.